Hey, this is Andrew Brown, and we're taking a look at what is a foundational model. So, a foundational model is a general purpose model that is trained on vast amounts of data. We say that a foundational model is pre trained because it can be fine tuned for specific tasks. So, just remember we are training the model, and we're going to say that it's a pre trained model. But imagine text, images, video, structured data, all sorts of data, massive amounts of data that is going to produce your foundational model. And from that foundational model, it could do all sorts of things: prediction, classification, text generation. It might be limited to very specific things that it can do, but the point is that it can do a lot of things. And the reason I want to bring up foundational model is because you hear it a lot when we're talking about LLMs, and it becomes a bit confusing how to distinguish it between LLMs and a foundational model. But LLMs are a specialized subset of foundational models. They are foundational models that uses transformer architecture. So if you remember that LLMs are foundational models, but they're specifically using the transformer architecture, then that will help make a whole lot of sense, okay? Let's talk about large language models. This is going to be short. Even though there's a lot you can say about it, I just want you to remember a key thing about large language models. So a large language model is a foundational model that implements the transformer architecture. And we're going to spend a bit of time learning about the transformer architecture in upcoming videos. But the idea is that you have natural language. I can get my pen tool out here. So we have natural language as our input. It goes to the large language model. It predicts output for words. And as it produces each word, it feeds it back in and continues to produce until it is done. So during the training phase, the model learns semantics or patterns of language, such as grammar, word usage, sentence structure, style, and tone. That's what makes it so good at interpreting language and giving things that sound with language understanding, because it has that ability to understand the semantics of language. It would be simple to say that LLMs just predict the next sequence of words, because as you use the model, it outputs a word on the end of it and keeps feeding it in and in and again and in until it's done. But the honest truth is researchers do not know how LLMs generate their outputs, because there are so many layers and there's so much going on there that at this point right now, the level of complexity makes it very difficult to truly understand how it is reasoning its output. But it looks like it's just doing word for word, but there is a bit more to it, okay? But there you go. The transformer architecture was developed by researchers at Google that is effective at natural language processing due to multi-head attention and positional encoding. And here is that architecture. It comes from that white paper. Attention is all you need, because that is the special mechanism that it is utilizing to pull off the feats that it is doing. I try to remember what came before it. It was like CNNs and RNNs, so convolutional neural networks and recurrence neural networks. And recurrence neural networks could kind of do what transformers do, but they just had an issue with scaling and being able to remember everything that they were looking at. And so this architecture found a way to do that, and that was with positional encoding and multi-head attention. How important is it to know this architecture? It's good. It's nice to know so you get a bit of an experience in terms of what's going on there. But to be honest, working with LLMs constantly, it's just like you kind of forget about this. And so it doesn't really inform any of your workflows or decisions. I guess it's just more like by looking at this, you have more confidence at reading white papers, right? And looking at some of the stuff of these architectures. So that's why we're looking at it. But transformer architectures are made up of two components or two parts. We have an encoder, and that's, you can get my pen tool out here so it's very clear what we're looking at. But it's this thing here, right? So that is our encoder. I'm just going to erase that there. And so you can get the idea that the one on the right is going to be our decoder. But let's read about what the encoder is. So it reads and understands the input text. It's like a smart system that goes through everything it's been taught and picks up on the meanings of words and how they're used in different contexts. So that's the high level. And then the decoder, based on what the encoder has learned, this part generates new pieces of text. It's like a skilled writer that makes up sentences that flow well and make sense. And as far as I understand that, once you put your data in here, it comes through here, right? And it has to be already embedded. And then once it goes through here, it's going to output that stuff, and it's going to go into here, and then each word, as it iterates through, it's going to go through here. Each word's going to go here. It's going to produce your sentence with the next word, and then it's going to go all the way down here, and then add the next word, and then feed all of this back in, and again and again and again. So it's just going to keep looping until it runs out of ability to write, or it decides to stop. And there are very specific components that we're going to look at, the multi-head attention in the positional coding. So we didn't really describe them here, but there they are, and you'll see them up close here in just a moment, okay? So tokenization is the process of breaking data input, and in most cases, text, into smaller parts. So here on the right-hand side, imagine you have a string, and you're going to break it up into its parts, which we represent as an array here. And then we're going to give it a unique ID to the model's vocabulary. So when we're working with LLMs, you have to tokenize inputs. And depending on what LLM you're using, it's going to use a different tokenization algorithm. So for example, if you're using GP3, you'd be using byte pair encoding. If you're using BERT, you'd be using word piece. If you're using Google T5 or GPT 3.5, you use sentence piece. You won't really notice this when working with LLMs, especially if you are utilizing something like Ollama or a managed service, because these APIs are taking care of this algorithm for you. So you just input it and it works there. But when you're working with LLMs, the input text must be converted or tokenized into a sequence of tokens that match the model's internal vocabulary. What are we talking about when we say internal vocabulary? Well, when an LLM is trained, it's creating an internal vocabulary of tokens of all the stuff that it knows, right? Because if you consume the world's knowledge, you want to take all that knowledge, that text, break it down into all its unique components, tokens, and then assign a value to it. And so these large models could have between 30 to 100,000 tokens. It could even be more than this or less depending on your model. But tokenization is very important so that it understands what's going on here. There are some things that we could talk about, like what happens when it encounters a token it doesn't know. But for the most part, this is tokenization that you need to know, okay? Let's talk about tokens and capacity because it really matters about how much you can produce. So when using transformers, the decoder continuously feeds the sequence of tokens back in as the output to help predict the next word in the input. So what are we talking about here? So here, imagine we have our input as the quick. And so we feed into the encoder. The encoder is going to produce semantic context so that the decoder knows what to do with that text. And then the decoder is going to output the next word. So this is the quick brown. And what it does is it feeds that sequence of tokens back into the decoder and produces the next word, and again, and again. And so the question is, what is the capacity required to run this? And so there are two components that we care about, memory and compute. So for memory, each token in a sequence requires memory. So as the token count increases, the memory increases. The memory usage eventually becomes exhausted and you cannot produce anymore. Okay, so now for compute, models, a model performs more operations for each additional token. The longer the sequence is, then the more compute is required. So a lot of AI services that offer models of service will often have a limit, a combined input and output, because it really has to do with the length of the sequence. So if you have a huge input, then you're not going to be able to generate a lot of words because you're going to hit that sequence token limit a lot quicker. So hopefully that makes it very clear about how memory and compute are intertwined with tokens. The way cost gets down is, they have to figure out a way of reducing or making the model more efficient. So that's helping to reduce the memory compute. There's other things you can do. So if you have a conversation that gets too long, what you can do is summarize the conversation and feed it back into there. So it doesn't exactly use all of the context of what it had before, but it can do something similar and help that conversation along, okay? So what are embeddings? Well, before we can answer that, we need to answer what is a vector. So a vector is an arrow with a length and direction. That is the simplest explanation. If you're talking to a mathematician, they're going to have a more fancier explanation. But the reason why this matters is that a vector needs to exist in a vector space. And so what is a vector space model? It represents text documents or other types of data as vectors in a high dimensional space. So right now we're only looking at a 2D axis, but in reality this would be in at least a 3D axis. But the idea is that we have these documents, and these documents represent some form of data, and they are plotted into our vector space with distances between them, okay? And the thing is, the distance between these other documents are going to correlate the relationship with them. So maybe these documents up here, I'm gonna get my pen out here, maybe all these things have to do something with, let's say, vegetables, and these ones all have something to do with, let's say, meat, and this is dairy products over here. So the way these things are organized on the in the vector space is really dependent on the type of embedding you use. So what are embeddings? These are vectors of data used by ML models to find relationships between data. And you'll find that often you're going to be using a machine learning model to create embeddings, and there's specialized machine learning models just for embedding. So you'll see something like Cohere, which is a company that produces or creates their own ML models. They'll have like command R, but they'll be like command R embeddings. And what it does is it takes an input and it outputs embeddings to be placed into a vector store. So different embedding algorithms capture different kinds of relationships. And so it could be, the relationship could be similarity in words in terms of the way they are spelled, or it could be the length of a word, or the relationship could be contextual, which is like, is the context related to a specific industry or vertical. So the embedding is going to change the relationship that is going to be projected into that vector space. And these ML models that produce embeddings are looking at not just like a single relationship, like let's say length of word, but multiple relationships and correlating that to put it into vector space. You can think of embeddings as external memory for performing a task for machine learning models. Embeddings can be shared across models, which would give us a multi-model pattern to help coordinate a task between models. But yeah, there you go. Let's take a look at attention. So attention figures out how each word or token in a sequence is important to other words within that sequence by assigning them word weights or token weights or attention weights, if you will. So I want to talk about three types of attention. We have self-attention, cross-attention, and multi-head attention, and some of these are combined. You'll see that in a moment. But let's talk about the first one. Self-attention computes attention weights within the same input sequence where each element attends to all other elements. And when you see this, it basically means that as attention happens, it keeps feeding itself right back into itself, the same sequence. So used in transformers to model relationships in sequences, so words in a sequence. You have cross-attention, computes attention weights between two different sequences, allowing one sequence to attend to another sequence. This is used in tasks like translation, where the output sequence decoder needs to focus on the input sequence encoder. We have multi-head attention, so combine multiple self-attention or cross-attention heads in parallel, each focusing on different aspects of the input. So using transformers to improve performance and capture various dependencies simultaneously. So how can we look at this in a practical way for our architecture for the transformers? So here you can see that in blue where it says multi-headed self-attention. It's multi-headed because it's receiving multiple inputs. You see V, K, Q, and I believe that the Q is like for query, key is for key, and V is for value. It has something to do with like how search engines think, kind of like if you were to let's say use YouTube and you were to type in a query there, it would match to keys, which would then return you back a value. So That is the best description I can give for it. It's self-attention because it feeds back its own sequence. It's going to be the same back and forth there. On the other side, we have multi-headed cross-attention. So it's multi-headed because it's receiving multiple inputs. So we have the VKQ, but it's cross-attention because it feeds sequence inputs from two different sources. Remember, it says that cross-attention is two different sequences. Well, we have V and K coming from the encoder, and then we have Q, which is actually coming from the decoder. So it's cut off here, but the idea is that the decoder is feeding itself right back into itself, and it goes through here into this one here, and then we get the Q, and it goes right there, okay? So again, it's not super important to remember this stuff. It's just to get you a bit of exposure to looking at these architectural diagrams and to see that there is a way to understand them, but they can get very involved, and it might be very hard to retain that information unless you are actually very invested in understanding and building these things, okay? When we're talking about large language models, there's this idea of fine-tuning where if we have a model that we don't like it, we can do something to it to make it work a little bit better. To understand fine-tuning and the ways we can fine-tune it, let's just talk about the components that are involved in fine-tuning. And so we have to first take a look at hidden layers and its components. So when training, you have layers of nodes, also called neurons, so think like your brain. And between these nodes, there are going to be connections. And so connections are often between or across layers, but connections can also be within the same layer. And that's where we get this concept of self-attention. If you remember, the concept of attention is really important when we're talking about transformers for large language models. And I mean, if we represent it, it'd be more like it's connecting back to itself. And that's why we call it self-attention, because it's a layer that feeds back into itself, which is self-attention, okay? But connections could also be where we have multiple sets of hidden layers, and these connections are computed in parallel. So the idea, I'm gonna just draw this here, but imagine we have another layer with nodes, right? And the idea is that this one will feed into that one, but this one's coming from here. And so now it's called multi-head attention because it's coming from multiple sources. And in fact, some of these, they'll come all the way back here and go like this and feed in. So, you know, that is ways that we can feed our data forward. Then we have parameters. So parameters are the weights of connections. So over here on the right-hand side, get my pen tool out again, we have a weight. And this weight is the representation of this connection between these two nodes. And so that's going to be a value. And so a connection might have one parameter, but they can also have multiple parameters. In most cases, it's one parameter. But you can imagine that for the amount of nodes that you have in each layer, they're going to have to connect to all the other ones in the next layer, and that's going to add up really quickly. Let's take a look at some transformer models or large language models and understand how many layers they're utilizing for training to get perspective. So let's take a look at GPT-3. So GPT-3 is not new. In fact, it is one of the smaller models that you can train still, like Babbage or DaVinci. If you go, like, let's say, use Microsoft Azure AI Studio and you want to do fine tuning, you can train GPT-3 models. And it has 96 layers, or at its large, and if we think about its parameters, that's 175 billion parameters. So you can only imagine how many nodes or connections are going on in there, but that's how many there are. And then we have BERT. So BERT has 12 layers or up to 24 layers. So BERT is still useful. It's a much simpler transformer that we can utilize. We have GPT-2, which has between 12 to 48 layers, so the same or more as BERT. Then you have Google's T5, which has 12 encoder and 12 decoder layers, or up to 24 layers there. So, you know, if we're talking about fine tuning, it's going to be tweaking the amount of layers, the amount of connections we're going to train, and things like that. But let's go define what is fine tuning. So fine tuning is retraining a pre-trained model's weights or its parameters on a smaller data set. So a model's weights is the outputted state of a model, but in this case, when we're talking about fine tuning, we're talking about a trained model's output. Okay. So then what is supervised fine tuning, SFT? This is where when we provide the data set, it's already been labeled, right? So Imagine we have a bunch of cats or like photos of animals, and so we're labeling what each animal is so that when the model is training, it's like it has a cheat sheet to know how to understand exactly what it is that it has. Okay, but so we're basically explicitly telling the model what the data is, as opposed to when we train our base model, that might be unsupervised, where we're not saying, oh, this is what this is, right? Because we're giving imagine trying to do supervised training on a huge data set, like labeling all. That would be very difficult. So the idea is that we will produce our base model first, or in the case of LLMs, the base model is the foundational model. So you're taking an existing model, a foundational model, and then we're going to train it. As soon as we have a foundational model or base model, and we decide to fine tune it, now it's being called a pre-trained model. Okay, so understand those terms. We have FM, okay, base model, pre-trained model. They're all in the same area. They don't necessarily mean exactly the same thing, but they represent the same thing at this place in time. So we're ready to take our base model and fine tune it. So we're going to bring in our smaller data set. I'm just going to clear all the ink off the screen here. And so the idea here is that we bring in that data set, and now we're going to train it, retrain it, and produce our fine-tuned model. Now, when I say we're producing these models or we're outputting these models, we're not actually outputting models, we're outputting the model's weights. Okay? We're not creating new models, we're just creating new outputted states of the model. And just understand that it often sounds like we're creating new code or something, but that's not necessarily true. So let's now talk about the types of fine-tuning we can do, because there's a lot of approaches we can take to fine-tuning. And this is not even exhaustive, but let's talk about changing the data set. So the data set itself, the data you're going to put in there, we could do instruction fine-tuning. That's where we take a data set and we tell exactly what we want as, like, let's say we say, I say this, you do that. So you're giving an example of what a person says and what the outcome is. So that's instruction fine-tuning. Then we have domain-specific fine-tuning. That's where you're taking a knowledge base or a data set of specific knowledge to update the model on that knowledge, or to make it focus more on that knowledge set, right? So if we had a generic LLM and we wanted to make it specifically for learning cloud computing, I could load it up with the most up-to-date cloud data, or even my own stuff to make it teach like I would teach, okay? Then we have changing the method of training. So we have full fine-tuning. This is where all the model's weights are updated, and it's expensive. So you say full fine-tuning, we can just think of it as traditional fine-tuning. You're basically taking the existing model's weights after the base tune as the starting point and running it through the training process again. Now you can add these two things together, right? You can do full fine-tuning and change the data set. They can be done together or both separately. It's up to you. We have parameter efficient fine-tuning, so also known as PEFT. You'll see this term come up a lot. It only updates a small set of parameters during the training and freezes the rest of the parameters. There is a subset of PEFT called LoRa, which we're not going to talk too much about here, but I'm just going to get you exposure to this. If you are not needing to update every single parameter, then you're going to save money there. Another way is last layer fine-tuning. This is where you will freeze all the layers except the last layer. And when we say freeze, we just mean we're saving the state at that point in time, right? Or we're telling it to skip until it gets to the last step. And then we're basically just training it on a single layer. And apparently that works really well. So there's a lot of things that we can do. Another thing we can do is we can do pruning. So this is where you're removing parameters, all right? And people might want to do this just to make the model smaller and more efficient, because maybe we can remove parameters and it will use less compute or be faster for some trade-offs. And there's two ways we can do this. Train time pruning. So somehow we are making the model to encourage to drop or remove connections or neurons during training. Or post-training pruning, which is basically you mangling the model weights file, the file that's outputted. So yeah, a lot of options here, but there you go. Hey, this is Andrew Brown, and we are going to take a look here at Amazon Bedrock, which is a model as a service, or you could say a large language model as a service offering, which makes it easy to deploy, customize, evaluate, secure, maintain various LLM models to integrate with your apps. Not everything in this is an LLM, so If you're using something like Stable Diffusion, that's technically not an LLM, but we're going to generally say this is for large language models because that is the main offering here. Amazon Bedrock can programmatically simplify working with LLMs via the Amazon or AWS SDK. So you just use something like Bodo 3 or the Ruby SDK or whatever one you want, and you just use the Bedrock API in there. And we definitely have hands-on labs, so you will see that. We have Llama Index, LangChain. So these are open source software that integrate with not just Bedrock, but a lot of stuff and has overlap with a lot of the feature sets with Amazon Bedrock. But we want to point that out, and we are going to get some experience with those at the minimum with them as well. So what does Amazon Bedrock have in it? Well, there's a lot of services in here, so let's go over it. The first is the model catalog. That's where you're going to be able to select a model that you want to utilize to do inference against or to make predictions against. You can create custom models where we have fine-tuning or pre-continuous training. We have playgrounds where you can utilize models without having to write any code. So that's for chat completion, just text completion and images. We have prompt management, so you can store, I would say, prompt templates. This is really good for creating a prompt template that you're going to test against a bunch of variables. So really good for testing your prompts. You have knowledge base. So this is basically RAG plus Azure OpenSearch or Azure plus a bunch of other things. So RAG plus some kind of data store. I wrote Azure OpenSearch, but I found out later on that it supports a lot of things. So I'll adjust the slide there. You have prompt flow, which is for orchestrating a series of events. It's basically a state machine. And so that's something that Llama Index can do and LangChain can do. But we have a lab on that, so you'll see what we can do there. We have agents, which provides agentic workflows. So basically you have an LLM and then you have conveniences around it. So if you want to quickly attach your knowledge base to your LLM without having to write a lot of code, you can do that. If you want to have tool use, you can do that. Things like that. We have guardrails. So these are pre and post filters so that you are controlling or remediating issues or blocking things that you do not like. We have watermark detection. We have inference where we have batch provision serverless cross region. We have eval assessments. We have the Bedrock Studio, which isn't preview, but it looks like it's a way of using the Bedrock, Amazon Bedrock without an AWS account. So basically giving access to the playground of Amazon Bedrock outside of an AWS account, but with a similar interface, but it looks different. But yeah, we'll jump into all of these here shortly, okay? Let's talk about the model catalog. Sometimes this is called a model garden. It just depends on the provider you're using, but the idea is that there's a collection of large language models or GenAI models, because again, it could be generative images or voice, and they're not necessarily using large language models. But the idea here is that you can choose which ones you want to use. So here, AWS has providers for its own Amazon models like Titan Premier, or Anthropic, like something like Claude Sonnet, Cohere, such as Command R, A1 or AI21, like Jamba, Meta, which has Llama, Minstrel, which has Minstrel, Stability AI, which has Stable Diffusion, and there will be more, I'm certain, in the future. And each of these providers have variants. So like you can even see in this screenshot here, we have Claude 3 Haiku, Sonnet, Opus, Instant. So there's a bunch of ones for each of these. Don't just think that there's just like 6 or 7. There's a lot. And before you can use a model, you do have to request model access. Different providers have different experiences with it. If you're over on Azure, it can take a long time, like 48 hours before they'll grant you access. Google is pretty much instantaneous, and AWS has been pretty much instantaneous. I think for some of them, like Cohere, I think I had to initially wait a little bit of time. So if it's a third-party provider like Cohere, you might take a little bit of time, but again, you can get pretty quickly operational here. We could compare these different types of models, but they're constantly changing, and so I don't want to date the information rapidly here, but yeah, there you go. All right, let's take a look at deployment models for Amazon Bedrock. And I just want to make it clear that there is requesting access to a model, and then there's the actual deployment of a model. And if you come from something like, again, Azure AI Studio, deploying a model is very, very clear, whereas in AWS, Sometimes you aren't aware that you have a model deployed, but for the most part, it doesn't matter because the majority of models have a serverless offering. So like they're on demand, but we'll talk about it here in a moment. So there are two types of deployment models. The first is on demand. So I would rather call this serverless because that's exactly what it is. And provision throughput. So this to me is more like on demand, but the idea is that you are basically spinning up servers. But again, it's abstracted away, so it doesn't feel like servers, right? Maybe it's containers or something. But let's talk about on demand. So these are models where you're paying based on the input and output tokens. This is how Amazon Bedrock mostly does its costs with these on-demand ones. It's input and output. And this is different because other providers don't do it. They just do it based on the amount of tokens generally. But I mean, this is basically the same thing, but the cost could be different on those two things. So example of a on-demand one would be Cohere Command R+. So you might be paying here a fraction of a penny per 1,000 input tokens, right? Or for output, it might be different, but the amount is different. So you can see that there is some variation here. You can track token usage in the Amazon Bedrock Playground. So I think we show that in the labs where I scroll down and I show you that. And also you can capture token usage information in Amazon CloudWatch logging metrics. And I absolutely have a hands-on lab where we don't do it, but I already have it set up and I just show you that what the information would look like. Then you have provision throughput. So here you're paying based on model units. So it's like, think of like Fargate, like serverless containers. They're abstracting away the actual server. So in a sense, this is also serverless, I guess. So maybe my my wording up here is not clear because they're both technically serverless. But I think of this one as serverless on demand because it scales down to 0, whereas provision throughput you're paying for as long as it's on, and that's why I wouldn't call it truly serverless. But the idea here is that you will say, okay, I want to provision this throughput. So you're spinning up compute that is managed by AWS, and it'll give you an estimate. And at that point, they'll try to ask you, like, do you want to have any kind of commitment terms so you can have a reduced cost, or how many model units do you need? So hopefully that is pretty clear. There's other things that we can do with deployment. I wouldn't call these deployment models, but it's just other ways that you can work with on demand. So we have batch inference. So this is for non-real time. We could say offline bulk processing. So maybe there's a tiny model that you can utilize and you just want to send it a bunch of stuff and get a bunch of stuff back. And so this is, again, for select small models, which is very similar to other cloud service providers. Then you have cross-region inference. So route the request to multiple AWS regions during peak utilization bursts. And at this time, I've only seen it. Now, I might be wrong here because at the time I made this slide, I did not turn on all the models, but for the most part, I only saw it for Anthropic Cloud. And so this could be dependent on the infrastructure, right? So maybe Anthropic has coded it this way, whereas maybe Cohere hasn't. And so just understand that it might vary, but it might not be true that it's only available for that. Not all models are offered in both deployment models. So, Cohere, I only saw it on demand, whereas Amazon Titan, I only saw it with provision throughput. And when I say Amazon Titan, I'm talking about, I should be very specific here because it's light or express is what that is there, because Premier actually is on demand. So again, it's just me making a mistake in the slide here and just quickly correcting it. But yeah, there you go. Okay. Amazon Bedrock Playgrounds allows you to interact with deployed model APIs without having to write any code. And Playgrounds allow you to quickly evaluate the use of LLMs for development, but are not intended for daily use or production. You can keep track of spend because it will tell you input-output tokens or the cost of provisioned throughput as you are utilizing these models within the playgrounds. The one playground you see here is called the chat playground, and there are 3 kinds of playgrounds. And to be honest, most models of service or LLM models of service will have these 3, or even any kind of playground or workbench will have these 3. So the first is chat or chat completion. This allows you to interact with LLMs that have chat completion. So that's pretty straightforward. You have text completion. This allows you to interact with LLMs to predict the next text. Before chat completion existed, all there was text completion. So when there used to be like GPT-3, when that first came out, there was no chat per se. But this is where you would predict just, again, the next word. Some playgrounds call these legacy playgrounds, encourage you to use the chat instead. So like if you use Cohere's playground, they mark the text as legacy. Whereas other ones just kind of treat it as another way that you can work with it. So some playgrounds will only let you use very specific models for completion, and then other ones only for text. That's what it's like over in Azure AI Studio. Whereas Bedrock, you can take a chat completion model and use it in the text section, so that's totally fine. This playground is really useful when you want to use LLMs for single term responses, or they might say text to text completion. So this is for classification, categorization. This becomes useful when we do fine tuning. So I have a hands-on for fine tuning, which I'm not successful in it, but not because of my fault, but I just didn't want to have a lot of spend. But you get the idea of where you use text completion for that. And then the third one here is images. So this allows you to work with LLMs that generate images. Pretty straightforward. And here's an example of the text completion. So you can see in this one here, we've written something, right? Okay, and then it starts to produce more text after it. So there you go. In this video, we're going to take a look at setting up Amazon Bedrock. So we'll go to the top here and type in Bedrock. Bedrock is a way to build out generative AI applications where you don't necessarily have to work with it programmatically initially, but they do have an API. Amazon Bedrock is a model as a service, meaning that they make multiple models available to you so that you can utilize them in a serverless way or to provision the compute that you need to run them. Depending on what region you are, you might have different models available. And I think that if I go to a region that I've not been in, you might have to request model access. So I'm just switching to one like Frankfurt that I'm not normally in. I'm gonna go ahead and hit get started. And what I want to know is like, do I have any model access? So right away it says, to use Bedrock, you must provide access to the models. I already have done this in US East 1 and CA Central 1. That's why I'm in a random region, but if you can just go to US East 1. You don't have to do this in Frankfurt. I don't recommend doing that there anyway. But what you do is you go to here, and you would then have to enable models. And so you can edit that here, but see, it says, enable all models or specific models. So you checkbox them on. So here, I'm just going to go ahead and checkbox a few here. But honestly, I would just enable all of them because we're going to be jumping through all of them. So, you can go here and just also select all of them as well. And it's pretty much very quickly how fast that access will get granted. So you'll see that I have it. I'm not sure if there's any that we're waiting on, but there are some that you may have to wait on. If you're using something like Azure's AI Studio, you have to actually submit a form and then wait 48 hours for very specific models. But here it can be very quick. But I'm going to go and switch back to US East 1 because that's where we should have the most models available. Okay. So now that I have models enabled, if we wanted to simply start working with one, we go over to chat here and we can select a model. Now understand that all models have different costs, so you have to be very careful what you launch up. If we go with Amazon and you're going to go with Premier, that one's going to be on demand, whereas if you go to Express, it is not on demand. On demand means serverless. You're paying per token, input, outputs, tokens. But if you go to something like Express, that has to be spun up with provision throughput, which is actually spinning up a container or a virtual machine or something like that. But let's go ahead here and just do a simple test in this video, and then we'll do more videos here explaining the differences here. So here, I just want to go ahead here and choose apply. And the reason I'm choosing Titan Text G1 Premier is that I believe that it might have free usage, but also if you do have AWS credits, it will work against this one. If you use a model that is third party, like let's say Cohere or Anthropic, you are going to pay money for those. So if you do not want to have any costs, do not use anything other than Titan Text G1 Premier. I'm going to be using a variety of them. So if you just want to watch and see what happens, we can do that as well. But let's go ahead and just type something here. We'll say, hello, how are you doing? And right now we are in the chat playground here, and we'll just hit enter. It says, I'm doing great. So that sounds good. If you scroll down below here, we can see some information like input tokens and output tokens. These are very important because they help us track our spend. And we can have some other metrics here, like how long did it take? And then if we go here, we might have other things that we might care about. On the right-hand side, we have some options like temperature and top P. This changes the level of randomness that your model will produce. Generally, 0505 is pretty good. So I will leave it here, to be honest, as kind of my default setting. But this changes, if we go here, maybe it'll explain it to us, but it will change based on how random it will be and like how much of the knowledge that it has baked into it, how much it will utilize, okay? So I do a better explanation of this when I'm doing my Azure course. I don't know why I'm so tongue-tied here, but the idea is that if you go one-to-one, you might get total gibberish. So say hello, right? And we'll see what it produces. And that looks okay. If we go down to 0 and we say hello, we'll see what we get. Hello. A better way to evaluate these randomness things is to go over to text. So we have 3 playgrounds. We have chat, which is for chat completion. That means that it's multi-turn, and I will say something, you'll say something back to me, and the conversation will continue on. We have text, which the idea here is to complete something. So if we go over to here, back into Premiere, I'm not sure if any of these are on demand. No, they're not. So if we click this here, we might want this to complete a sentence. So my favorite type of food is, and then if we do this and we run this, it says, I can't say that I have a favorite type of food, but see, it's just like spitting out a lot of text here. So not exactly what we want, but as a text playground, it just produces text. It's single turn, and we're not expecting it to do anything like that. So if we turn this all the way down to, let's say, 0 and 0, like 0, 1 here, let's see what we get. And yeah, it's not doing the best job here. I was hoping you do a little bit better, but we can come back and play with these and see what we can figure out. But generally, if you had a dumber model, and maybe that's what I'll do. I'm going to go ahead and run one. Now, I'm suggesting you not do this, but I'm going to go run Light, which is one of the most cost-effective, smallest models. But it still is expensive per hour, so you might not want to run this. But I have Light selected here. I'm going to try this again and see what happens. So we'll go ahead and hit Run. And here, it's at 0.9, so we'll go ahead and try to change this and run it again. Okay, and so I'm going to go here and just say my 3 favorite types of food are pizza. Okay, let's see if it can work with that. Burgers and sushi, there we go. So that's now it's getting a little bit better. If we turn up top P and temperature all the way to the top, try this again. Burgers and fried plantains. So notice that it's getting a little bit more creative. This is a lot easier to show when you're using something like Babbage or other GPT-3 models, but we don't have access to those here. But if we were using those ones, what you would see is that it would, at the lower one, it would choose the most obvious things like pizza, spaghetti, whatever. And then when you went to more random ones, it would choose more creative solutions. But anyway, this is just an introduction video to get you set up here. I don't want to use any more of this, so I'm just going to go over to here. Not that it was doing anything fancy there anyway. And I'll see you in the next one, and then we'll actually do some real things here in Amazon Bedrock, okay? Hey, this is Andrew Brown. This is a friendly reminder to make sure that you are stopping your Jupyter Lab notebooks so that you are not getting spend. So as long as you stop them, they will not be causing you spend. There is attached storage. So, you know, if you need to be fully concerned about cost, you can completely delete the workspace. I'm done with this one, but you know, you will see me in videos using this Bedrock workspace, and I'm not going to be stopping it because I'm going to be making video after video after video. So I'm just telling you here that I'm not going to be doing that, but you should stop it so that you are not having spend. Okay, so yeah, that's just your cost warning there. Okay. Hey, this is Andrew Brown. We're going to continue on using the Amazon Bedrock workshops. I already have everything running here. I'm just going to go back to the top level directory here, and we're going to go back over to the workshop and take a look at what's next. So the next thing is about text generation. And so here we can see that there are a bunch of things that we have here. There's some stuff that we've already kind of done, like we did the 0-shot generation. But let's go take a look and see what we can do that is different. It looks like here they are integrating with LangChain. So this is another way that you can work with Amazon Bedrock. Personally, I like Llama Index. but LangChain is totally fine as well. So we'll go ahead here and we'll make a new folder and we'll call this text generation, and we'll just modify the code based on what we want to do. So the first one is 0-shot gen. So we'll go ahead and make a new notebook here, calling it, whoops. We'll go ahead and, no, that's fine. We'll just drag it into the correct location. And we'll just rename this to 0-shot generation, or gen for short. And we'll go back over to here and we'll click through to this one here. We might already have it open as a tab. We do not, but I'll just close out some of these tabs here. Leave this one open. We seem to use that one a lot. Here we are on the left-hand side. So let's take a look at what we have. And so we were starting to use this already, but here it was suggesting that it was using LangChain, right? Yeah, see, they're using SageMaker Studio as well. This one's using Amazon Titan Text. Where's the LangChain? Let's go back over to here. Bedrock and integration with LangChain. Okay, where's the LangChain? So this one is a very simple example where they are doing what? So here, yeah, write an email template. And to me, that's fine. But maybe we could go use this with something other than the Amazon Bedrock thing. So you know what? I'm going to do what they didn't do, and I'm going to go ahead and actually use LangChain. So let's go ahead and learn how to use that. I usually use, again, Llama Index, so I'm not the best at this one, but I'm sure we can figure this out very quickly. So what LangChain is and Llama Index is basically like an adapter to many different types of LLM models. In fact, it kind of conflicts with Amazon Bedrock because Amazon Bedrock gives you access to a bunch of models, but LangChain ecosystem and the Llama Index ecosystem is a lot more robust for stuff. So what I might do here is just rename this and forget the 0-shot thing because we already did that. We'll call this LangChain as this example, and we'll figure out how we can do this very quickly. So what I want to do here is just get started with it, how-to guides. Any kind of code examples, and I'm not getting anything here, so API reference. How do I get started? Just show me an example. Come on. Let me find some stuff here. Give me a moment, okay? All right, just click through the first one here, which is simple. And so the first thing I want to do is install it. So we'll go use pip here. And we'll put this here. And so that should install LangChain. We'll choose the Python 3 kernel. And so that will get us started. We're, of course, going to want to have, I don't know if we need to get Bodo 3. So maybe we'll leave that alone for now. But let's go take a look at the next step here. You know what might be better if we type in like LangChain Bedrock example. Here we go. So here we have pip install. It seems like we also might need this. So here it says text completion. We'll go to chat completion. Hold on here. So you're currently on a page for model text completion. Many popular models available on Bedrock are chat completion. You may be looking for this page instead. Okay. And here it says chat Bedrock, which is fine. And technically we are doing text completion, so the other one was totally fine. But we'll just continue on here. So down below, it looks like they have a specialized library. So LangChain Bedrock integration. So we'll go ahead and grab this. And I mean, we'll just put them on separate lines. I'd like to do that most of the time for this kind of stuff. And we'll go ahead and grab this example next. And by the way, I'll grab this URL just in case you folks are looking for it. Drag this all the way to the top. And we'll change this over to Markdown. There we go. It says, does not currently take into account packages that are installed. This behavior is the source following dependency conflicts. So it seems like this behavior is the source of the following conflicts. So I'm not sure if that means that because that one was installed, it's conflicting. I don't know. So what I'm going to do is I'm going to take this one out. It's very unusual. I might have to restart the kernel completely. Restart the kernel. Okay. Sometimes, like when you reset the kernel, this things might still be installed, so we'll see what happens here. Okay, and so this one's not causing any problems. I just want to point out that if you do this and you don't have that other one in there, it might still break, just because of the nature of Jupyter Lab notebooks. So hopefully you don't run into any problems here. So here we have an example with Claude Sonnet 3. I believe that this is still recent, so that looks pretty good to me. I'm going to call this client. I kind of prefer it to being called a client. And down below here, we'll scroll down. Got unexpected keyword CLS. So we scroll up. I'm not sure what's wrong here. Now, are these the same model IDs? Like if I grab this one, will it match up to that list? It does. That's through purchase provision throughput. But it also matches here. So I'd rather try something that I'm more comfortable with, like Haiku. And so we'll go ahead and try this instead. And so here we're getting what? Why? And so this is where it's a bit frustrating. Again, like I personally, when I'm building out LLMs, I don't use Bedrock at all. I just use LangChain or Llama Index because it kind of negates the purpose of Bedrock here. But we will see what we can do here. I am using LangChain with Bedrock. I probably should have told it that first. And we'll see if it can figure it out here. I don't know why it keeps bringing that there, but we don't have Bodo 3 installed. So maybe that's our problem. So what I'm going to do, go all the way to the top here. Now let's do Bodo 3, and we'll also do LangChain. Let's see if that fixes our problem. LangChain. I'm going to restart our kernel, clear all outputs. We'll start on over. We'll try this again. And hopefully we don't get conflicts, because that's what I'm worried about here. We'll just give that a moment, okay? So I don't know if this error actually is a problem or not, so I'm just going to kind of ignore it, and I'm going to go ahead and try to run this again and see what happens here. I notice I didn't get a problem, so maybe this is just not a problem, but you know, my feeling is that these are the three that we'd have to get installed, right? So now we have our client here. Let's continue on and see if we can make this work. And so here we have an example. Okay, so here, translate a sentence from that to English. Just going to tweak this to be client as I prefer this. And this will be response instead. We'll just be kind of consistent with what we're writing here. And we'll go back over to here. And we'll say response, and we'll see what happens. There we go, so it works. So that's our simplest example of using LangChain. Now LangChain, the idea of these systems is that it allows you to orchestrate multiple agents together, reach out to databases, data stores, do all sorts of things. Amazon Bedrock has something similar, which is prompt flows and agents. But this is within the AWS ecosystem. Same thing with over at Microsoft, where you have Azure AI Studio. They have prompt flow, which has the same darn name as that one. And so these kind of compete with these open source ones. Again, the open source ones are a lot better. And so if you're going to build something for real, use LangChain or Llama Index. But that was our basic example of LangChain. Let's go ahead and make one with Llama Index now. So we'll go here and rename this. We'll say Llama Index, And we'll look for that example, llama index. We'll say Bedrock. And one place where I ran into trouble, like it works fine, but where I ran into trouble with llama index is that with Bedrock in particular, is that you cannot easily track tokens. And this is a problem with Bedrock, not llama index. It's just the way that Bedrock returns data, and whoever's maintaining that there. So here we're going to pip install that. I don't know what the exclamation mark does, but I mean, it seems like we would also need llama index, so sure. We'll go ahead and do that. I'm not familiar with all the different syntaxes. I just usually do percentage here. And so here we have a very simple example. And I'm going to go ahead and grab this one here as well. You can see you can launch this in Code Lab there. We'll go all the way to the top. And we'll scroll up. So we'll go here. And here it's talking about profile name. We do not have a profile because it's just being loaded internally here. So we don't need to necessarily put that. Here it's going to try to use Titan Express, and it wants to complete Paul Graham. I don't like Paul Graham, so we'll take this out of here and we will say something else. What is some other kind of text that we could put here? We could do anything that we want. So maybe we will place Star Trek here. See if that works. And so maybe we'll just print the response here. I'm not sure what we get back here. Oh, that one's still running. I should have been a bit more patient. If we go back over to this example here. Oh, they just printed out like that. Okay. And here they have a bit of a variation in terms of how you can do it. Is an American franchise based on, etc. So there we got LangChain and llama index. So that's good for those two types of text generation. We want to continue on and see what else there is that we can pull from value from these workshops, if there is any. So we will go back over to here. So we didn't bother with that because we kind of already did it. Here we have zero-shot generation that can leverage code generation. So here they're talking about generating out code. And then we have summarization. So this is something that we probably want to know how to do. I feel like that would be on exam. So go here and say code generation. Code gen. We'll do that one next. We just use the regular Amazon Bedrock API for that. We don't have to use LangChain or llama index, just to make our lives a little bit easier here. And so we will go back, close this one out here. And so I want this one open here. We'll see what we have. This one is using what? Claude Sonnet 3. Okay. And here they want to create a CSV file and generate out some code. Wow, this one's a bit more complex. So we have a few use cases. We have, what do we have? We have code generation. Well, let's separate those into two separate things. We don't need to have them all in one here. So I'm going to go back over to here. And we're going to go to our, I'm going to put this here to the left, to our code generation. And I'm just going to back out here for a second. And we will go up to here. And I will grab Boto 3. We'll drag this over. This one's fine. We'll just save that. We'll close a few of these out. So we'll do Boto 3 here. And we'll then import all these. Don't even really need a space there. I'm not sure why I did that. And then we need our client. Great. And then we'll go back over to our code generation examples. This is not the correct one. It's over here. Nope. This one is old. We'll go here. And so here it's saying, let's set up some CSV data. So we'll go do that. And we'll run this. Okay, so it's created a CSV file somewhere here, I would assume. Well, it's somewhere. As long as it knows where it is, that's all that matters to me. Oh, you know what? It's because we're in this directory. Here it is, right? So we open that up, and so this is sales data that it just created, which is fine. We'll go back over to here. And so then we have our prompt. So we'll grab this. What is it doing? So you have a CSV of sales data with the following columns. Create a Python program to analyze the sales data from a CSV file, and it tells it some instructions as how to do that. We'll bring a new tab down here. We'll go over to here. We'll grab this, which is our body. So that looks fine. This is all fine, I suppose. And then we'll go here and we'll grab this text and we'll see if we like it or not. So here we're bringing in IPython display. So that's going to allow us to have some kind of interesting display markdown. So it's going to format the markdown. We have the model. We have JSON content type. This is fine. We can bring this down on new lines here. And I like to bring this into a separate line here. It's just easier to debug when you have them separated out like this. And then this line here can just be with this here because this is what it actually is for. And if we run into problems, we can now debug this. So just say resp here. And this will be resp. This is just body. And then we will assign that body. Okay. We could put one line between that there. So hopefully this works well. You know, we'll just keep updating this here, making this a little bit nicer. I think this is missing the C here. So we take that out there. And that's so much easier to read, I think, anyway. So we'll continue on here. We'll take a look. And we'll run this. And we'll run this. It says Bodo 3 Bedrock. That's because we just call it client here. So we'll try that again. We'll give it a moment here. And we'll run this. And then we'll run this. And so, oh yeah, it actually outputted code. So this is the code that we could use to analyze it. Now the question is, would it work? Right? So now the next thing we could do is we could grab this code, outputted code, and then we could see if it actually works. So let's go run this and see if that works. There we go. Okay, cool. Yeah, nice. So pretty simple example of code generation. Another one is SQL generation. So let's go ahead and make a new notebook for that. And we'll say select. And it might have a lot of the same stuff, but I like to always separate these out so they're just a little bit easier to read here. And so we'll go back over to here. Oh, and I guess they just, yeah, they pasted that there as well. I didn't realize they were going to do that. So this one is going to be similar, but instead it's going to generate SQL. So we'll go back over to here and we'll just start grabbing stuff. So this will grab, and this will grab, right? And then we'll grab this. And then we'll grab our CSV creation here. And then we'll go down here and we will, now this is where it changes, right? This is where the prompt might be a bit different. And so we'll go back over to our example here. And we'll grab this prompt. And notice the format's different. So I'm thinking that maybe this is a different LLM. So they have a database, generate queries based on that. There is no database, so we'd actually have to load a database for that to work. And here they're using Titan. So they've actually changed what they're using here. So we'll go back to here, we'll hit enter. And that did not copy correctly. We'll try that again. And the indentation looks a little bit crazy to me. I don't think it's supposed to be indented that much. And I'm going to go up here, sorry, to this one. And not this, but we'll copy this one here. We'll bring this over. We'll go down here. We'll go back to here. Where is it? Here it is. And we're going to use Titan large. And again, as always, if you're uncomfortable with utilizing any kind of spend, you can always just watch here and learn, right? So that's going to be the same thing. Response is going to be very similar. The only difference is this here. So I'm going to go here and just add a couple, maybe 3 here. And so we'll go back to this one, and we're going to read the body as such. And then the body results is like that. Take that one out, that's not necessary. And so hopefully this just works. That'd be super sweet if it does. Okay. Then we have our prompt here, and then this one, and then this model. Hopefully that just works, fingers crossed. This one, and there you go. So it's opening SQL. Now we can't test this because it's not in a real database. We could like load in SQLite and then try to run it against that, but I don't want to fiddle with that today. So now we have code generation done. We'll go back over to here. And we'll go ahead and try summarization. So here, let's take a look here. How's it different? Here it's just going to summarize text using Claude Sonnet. So this one should be pretty easy. So we'll go ahead and make a new notebook. We'll just call this, we'll say select. And this one would be called summarization. Summarization. And we'll just continue on the same pattern as we always have here. So grab Boto 3, even though we don't need it. It's already pre-installed. We'll grab this. We'll put this here. We'll go to the next one. We'll grab that there, Boto 3. We'll go back over to the code. We'll take a look here. And for text generation here, it is invoking a model. So we'll grab the body here. And we'll bring this onto a new line. And what do we called in the other ones here? This is called what? Oh, it's just body JSON dumps. Okay, so we'll go here and do this. We'll bring this all the way back. This is crazy how indented it is here. And we'll put a parentheses here. And so that fixes that, that format here. This is where you put your input text. I was hoping that this would be a bit better. Are they just showing an example of one? Request syntax of an, oh, this is just the syntax. Oh, freaking jeez. Come on, fellas. Who writes this stuff? I don't know. SDE's level 1, sorry. Okay, so we'll go here and bring this down here, and we'll go back to the prompt. I don't like how their labs aren't consistent, consistent with naming between them. Kind of bothers me, but that's just me. So say prompt data here. We'll bring this down onto a new line, and then we'll just put these here so that formatting makes sense. So bring this back to the wall, bring this in here. We'll get rid of this one. Oh, so the text generation here is like this. Hold on here. Did we mess this up? Nope, it's on the outside. Yeah, each one is a bit different, right? So here, this is going to be indented like that. I don't see what the problem is here. It's just trailing white space. So yeah, no problem per se. Okay, so that one's fine. We'll keep running these. And we'll go down to body here. And so now we're on to the next step. And so this one is using Amazon Titan, which is fine. We're going to go ahead and grab our nicer looking code. So we're just doing this with here. So we'll grab this. Yeah, it's still using the same model, I think. And so we'll grab that. I thought they were going to use Claude here. Invoke it. And they get the body back, and then they read the output here. So it's just a slide up there, sorry. So we'll go back over to here, and we'll bring this down a couple. And this is going to just be body, as we know. But what we want here is this line here. Okay, you can see this is way, way easier to read and look at. And so we'll run this. And then we'll run this one. I'll run this one. So the idea is it's taking this text and then it's summarizing, right? Do not add any information that is not mentioned in the text below. So yeah, simple summarization task. It looks like there's also one by Sonnet. So I guess we could do that as well. Notice that this one uses XML tags, so I suppose that we could do that here. I don't really want to. One's good enough, but just point out that like summarization for Claude, Sonnet, likes to use XML tags, right? You don't have to, but this is using 3. So I think that's pretty darn clear for that one. Let's go take a look at the next one. So here it says, we did summarization, so we have simple questioning and answering, so we'll do that next. And we will go back over to here. So we'll make a new file here, call this new notebook, call it Q&A. Q&A. And we'll go through this here. This is a Q&A example. So, okay, why do we need to import warnings? What is warnings? Oh, it's just saying ignore warnings. Oh, that might be cool. I'm going to ignore that because I don't care about the warnings, but if we do see them, then we know where it's actually helping out, okay? So let's continue on here, something similar. So we'll grab this, paste this in here. We'll grab all this. We'll paste this in here. We'll grab our client and we'll drop that in here. Let's go over and see what we have for our Q&A. So here we have our prompt data, which is here. So you are a helpful assistant. Answer questions in a concise way. If you're unsure about the answer, say I'm unsure. How can I fix this answer? Okay, great. And then we have our parameters, which for whatever reason, they are doing it this way. Yeah, so normally we would have this on another line here. So we'll go ahead and do that. And then we have our parameters. Again, I'm not sure why there's inconsistency between them. I guess other people are writing these labs. And we'll grab this here like that. We'll indent these here. Okay, and so I believe that that is proper. And so now we want to bring in this. So this should be basically the same. So we go over here and drop this in. And then we can bring in this here because we're obviously going to want to analyze the body. And I wonder if we could just get output text here. I am unsure. Wow, okay, so here, I mean, maybe it's supposed to do that, but how can I fix a flat tire for my Audi A8? So, you know, it doesn't have enough contextual knowledge to know that. Yeah, so it says, I'm unsure, and that's what it's supposed to do. Another issue can be trying to ask the same question for a completely fake car brand, say Amazon Tiara. And so here, it looks like we are entering more than one prompt. So we'll go ahead and, yeah, so that's probably why they extracted out the parameters here earlier, because they're probably entering them in again and again and again. So I guess I can do that here and just say params. Now that I see why they're doing that, it's because we're doing multiple ones of these. And so here, this is going to be params. And just to make this even easier, I'm going to go ahead and grab this here. I don't normally put it here, but we'll put it right here. I think we can do that, right? And I think it's just this indentation doesn't like it. Here we go. And so that way, what we can do here is now just copy this and just change out the parameter, right? The prompt data. So what we'll do here is try another one. So we'll go down below. And then this one will be new prompt data. And in here we have this one. And normally we don't do it this way, but I'm going to go ahead and do it this way here just to make our lives a little bit easier when we're working with multiples. The reason I like them on single lines is that it's just easier to debug them if you run into issues. And then here we'll just also do this as well. So we'll grab this here and place this here, just because we're going to be doing this more than once here. And then I can grab this here and put this here. There we go. And so we'll just make sure this still works. So I'm going to go ahead and delete this. So run the params, and then we'll run this one here. I'm unsure, and then we'll run this one here. Give it a moment. The other one ran really fast. Makes me think that it cached it. And it's thinking for whatever reason. We'll give it a moment, okay? There we go, came back. So here it says, so it's giving us instructions for a car model that does not exist. So that's what it's saying here. So here they're talking about like a method to fix it. So the following is an excerpt of the manual. So what they're suggesting here is what, to put the information in here. So like if it doesn't have information, then we provide information. So let's see how, okay, so as you can see, the answer provides is not plausible. It can be augmented on the fly by providing additional knowledge base as part of the prompt. So the following expert of the Audi A8 manual. We take the text and embed it into the prompt together with the original question. Okay. So here we have context. Okay. So we're providing it information. And then we have our question. I mean, we could just simply do this another way, but yeah, this is one way that we could do it. And then we'll go here and grab this here. And we'll run this and see what happens. It seems like it's missing then. Okay, yeah, to fix your flat tire for your Audi, this is what you can do. So just understand, like, you can give knowledge part of the context window, and that's how we'll be able to do stuff. The thing is that if you have a lot of information, depending on how much the context window can support, you know, sometimes you can't fit all that information in, or it makes the computation very expensive, and that's where fine-tuning would be very useful. So we have this. What do we have here? So since the model takes a while to understand, this might lead to poor performance, kind of what they're talking about. It was pretty quick, though. Bedrock also supports streaming capabilities where the service generates out as the output generating tokens. Okay, that's cool. So what that would do is it would print it as it comes, I think. So let's give that a try here. So go here. And is there anything different in here? Let me just take a look here. Nope. So I'm going to go ahead here and just grab this here like that. Okay. And I'm just going to type in response. And so here it's returning the stream. But I would have thought there would have to be something different here. Let's go back and take a look here, just carefully. Take a look here. Invoke with response stream. So there is a difference. It's this. And so now let's take a look and see what happens. This one here, yeah, it's still prompt data. This is all fine. So we'll try this again. And so it should make a markdown file and then stream it out to us in place. So it was very fast. So it's suggesting that maybe it was slow, but clearly it's not. But if it wasn't slow, it would be printing it out like word for word here, okay? So I don't know. I'm not sure how I would show that to you, but clearly it's fine. Looks like there's still one more to do here, and we're almost done with all this text extraction. So NLP technique to automatically extract specific data with natural text. Okay, so let's go take a look at this one. So this, I think, is called NER, so Named Entity Recognition. Is it? I think this is NER. I don't know if it's NER, but I'm going to call it NER because I'm pretty sure that's what it is. So say NER. Well, this says extraction. I guess we'll call it entity extraction. Okay. And so we'll go back over to here. And this one's using LangChain. Oh, why? Why are we using LangChain here? Is a technique that automatically does this. So we'll go, let's just take a look at what the code does. So we're using Bedrock. And then we are using LangChain here. And then here we have a path. And so we have some kind of data here, maybe emails. Here it is. Okay. Given the email inside the triple backticks, please read it and analyze the contents. And then we have beautiful soup, which is a way of extracting out information from, it's a parser, I believe. It's like the equivalent, yeah, HTML, XML parser. It's like no Kogiri of Ruby. And we'll extract by tags. So if we go to these emails, are these emails in some kind of HTML format? No, they are not. If we go back to this one, I don't know why all of a sudden they've done LangChain here. So here, all right, we're going to try to do it, but I'm not going to use LangChain for this. We'll just do it the normal way and see how we can translate that over. So we'll go all the way to the top here, and we'll grab this. And we'll grab this. It looks like they were using Bedrock, or sorry, LangChain in a different way that we were using. I'm not sure if they just have old code there. And so what do we want to utilize for this? This is using Claude Sonnet. Right, so we're going to go back over to here. Is there one that we use Claude Sonnet? We used one with Haiku. I think it was probably like LangChain or something, right? Yeah. So that's fine. I'm sure we can figure it out. Let's just go back to prompt engineering. Did we use it in here maybe? Chain of thought. Here we use Haiku. So maybe we'll use Haiku. Haiku's more efficient, and it's probably the right thing to use, to be honest. So I'm going to grab this one here instead. Okay, and all the parameters in here, so we don't have to have anything above it, right? Yeah, we don't. But we do need to have the prompt set up. So we'll go back to our entity one here, and we'll go down a line. And we'll go back here and see what kind of prompt we have. So I want to grab this one here. This is the basic approach. And here it says messages. Huh. Oh, and here's the messages here, right? So I can just go here and type in messages. And then what we do is we'll just take this out like this. There we go. And I'm not sure why we're using these weird parentheses like that. Let me just go back for a second. I'm just going to change this to curlies. Okay, and so then this will be this. Maybe that's just like an alternate way of formatting it, but I'm not going to do it that way. I want to do it this way here. And we'll bring this down here. Again, not a super Python programmer, but I seem to be able to figure things out no problem. And so this one's a little bit different where it specifies a role. So we say role like this, system. And then here we're going to have our text. I guess the other one was more concise, but again, I don't really care about that. I just wanted to be clear, not concise in this case. And we'll take off this curly here on the end. And then we need a comma, which we do have. And so then we have this one, which is human role. And then we'll go here and put a comma and say text. We'll go back to this one here. And the query is this here. So literally I can just grab this here and place it in, I think. Maybe I have to place it in like this, yeah. And so I'm not sure what its problem is. Oh, there's no problem now, is there? Try this again. Let's run it again. Undefined string literal. There's something wrong here. Oh, you know what? I'm missing this here right there. Does that fix it? Doesn't like the backticks here. Why not? Well, it doesn't know what book email question is. So that's just probably like loading the data above it. Yeah, it is. Okay. So go here, and now we need to bring in those emails. We only have a couple, so I'll just manually make them here. Say emails. And by the way, I'm in the wrong folder, so let's just go ahead and delete this here. And we'll go back a level, and we'll go into text generation, and we'll make a new folder. I'm not even sure why we even need to load these externally, but I guess it's kind of an example of loading in external files. And so I'll grab this one first. Rename. And we'll grab this one. Okay, and so now we have those two files there. Did we grab the code to load them in our entity file here? I know we have a lot of tabs here, so I'll just close some of them out so we can see what we're doing. And I need in here the loading the files. Here we go, this part here, right? Whoops. Get that out of here. And so we'll bring this down here. And so we're going to load those there. And so now if we, oh, this is LangChain. This is the wrong file, sorry. It's not going to hurt anything, but we'll bring this back over here. I'm noticing it's using that format here, so I guess we did use it somewhere before. I just never noticed, I suppose. And I guess we already have it here, so I'll just delete that out. And we'll run this here. And then we'll run this one. And so now we don't have a problem. So we'll bring this on down. Okay, so this one's ready. Did I mess up one of these other ones here? Just making sure I didn't muck them up. Okay, good. Because I remember pulling out messages here. So oh, it's there. I just didn't do this. Okay, so now we have this set here. And take that comma out of there. It seems like it doesn't like that comma. It's just a white space. Is that its problem? Where? Whatever. I don't think that matters. And so let's go ahead and run this. Messages. System is not a valid enum. Human is not a valid enum. Okay, well, if that's the case, maybe we could just switch this over to Sonnet, because maybe Sonnet has slightly different inputs. I would have thought Haiku would have had the same ones, though. Seemed like they did. Let's go ahead and swap this out. System is not a valid enum. Okay, so we'll go back to this one. We'll take a look again. System, human. You sure about that? Okay, so what we'll have to do is go back and just take a look here. So I'll just say Claude, Sonnet, Haiku, messages. Maybe somewhere in their docs they have this example here. Anthropic docs. API. And I know like this is a different API, but notice here it says role user like this. So that makes more sense. Not human, but user. See, that seems more valid to me. It's human. And then the other one here is going to be whatever the other one is. So somewhere here, there's roles. And so I'm just looking for the types of rules there are. It's kind of hard to find. We'll just ask ChatGPT. When using Claude Haiku 3, what types of rules can we provide in messages? So we have assistant, user. Can you give me a code example? Okay, that's not what I want. Because sometimes like you have 3 roles, you have assistant, and user. And so that's what I'm looking for here. I'm going to go back over to ChatGPT, and I'm actually going to go choose Oak Preview because that one's a bit smarter. I am using Amazon Bedrock with Claude Haiku 3. Can you tell me the names of the roles that I can use in messages? Show me the programmatic name for the code. Because I don't want a description. So give it a moment here to think, okay? All right, so it's still not providing the format that I want. No, there is like a JSON format for messages. You know, e.g. role, like user. I don't know why it's not. Okay, whatever. I guess giving it any kind of format like that complains. Let's see if it can figure out what I'm trying to say. We can just make it assistant, but I just feel like that's wrong, right? See, this one's a system. And maybe the reason it says system and human here is because we're using LangChain and they're normalizing for whatever they use, right? Here it's saying system. Okay. Well, we could try it again here. And here it says content, not text. So let's try this and see what happens. Okay, so I'll give it this here, see what it says. Oh my goodness. And I can't, let's just say this. I guess it doesn't like the JSON stuff right now. And we'll see if it can figure this out. An error occurred when calling the invoke model operation malform input request. Subject must be a valid scheme. Required messages. Role system is not a valid enum. Okay, tell me what they are. You know what I mean? So we'll go here and look at Bedrock API for Haiku 3. And maybe somewhere here, role user. So they're not showing us everything. It's very frustrating. And that is not useful. We'll go here. And this is not useful. Just give me a second, okay? I'm going to try this with Sonnet again. Maybe, again, that because it's saying like, oh, it doesn't do it. It only works with plain text, which I'm not sure if is actually true. So I'm going to go try and switch back to the model IDs for Bedrock and see if that fixes the issue. Because maybe it's Haiku 3 that uses plain text, right? So we'll go here and we'll try 3. Not 3.5, but we might switch over to that in a second. Okay, what a pain this is. And it does not like it. So what I'll do here, as this is really frustrating, but you know, like, again, we don't have to do what they're doing. We can modify our code so we can get it to work. But here they're suggesting to just provide the prompt as text. Oh man, you're a helpful assistant, then human. Okay, so we'll try this. So given the emails in this, and we'll just try this. We'll say assistant. And I'll grab this here. And we'll write that here. Not how I would like to do it, but that's just a way that we can do it. And then we'll take our prompt here, and we will provide it into the correct location, which I'm not sure. So we'll go back to this, body prompt. Okay, so we'll try this. And what if we take these out? Can we take those out? We'll just copy what they have here. I really wish they didn't use LangChain for that. And we'll run this again. It's not supported for that one. Okay, what if we just take these two out? Now what do we get? Wow, this is so frustrating. This is unbelievably frustrating. Okay, so what I'll do is I'm going to go back to prompt engineering, and let's just walk through some examples and see what we have. So we have this one. This one's using haiku, right? And we have text up here. So maybe this is what I want. I'm going to grab this one here, but then it just puts everything in the user message, so it's not really providing the assistant here. Whatever, as long as it works, I don't care, I guess. And so we'll go back over to this. And just grab the whole prompt here, I guess. Try this again. And so that one is fine. We will grab this here. Put this here like that. And we'll grab this one here. We'll grab that. The book mentioned in the email is Treasure Island. Return it, otherwise don't do it. Okay, so it did that, which was good. Model specific prompts. So let's see what it says here. While basic approach is good, this is a more optimized prompt for it. So here we have another one here. I don't know. I guess we extracted text out here, and that is good enough. I don't feel like doing more here, so I think this is sufficient. And we'll call this one done, entity extraction. And we have now completed all of text generation. So be very excited about that and be very proud for all that completion there. I'm going to go ahead and make sure I download all these first. So let's go ahead and download these. So I'll go here, and maybe I can download the whole directory. Let's see if I can do that. Download. Can I download that? Nope. So I'll say download, and download, and download, and download, and download, and download, and download. And I'm not going to copy the emails over. You can get those yourself. It's not that hard. And so we'll go back over to AWS examples, wherever that is. Here it is. And I'm just going to go ahead and make a new folder here. This will be called text generation. And I'm going to upload here. Just be back in just a moment, okay? There we go. We'll go ahead and save this here. And I'll see you in the next one, okay? Ciao. Hey, this is Andrew Brown. In this video, we're going to take a look at using Amazon Bedrock, specifically using the project knowledge base to implement RAG. I'm going to tell you right now, this is not an easy thing to do, so we'll do our best to try to figure it out. There is a programmatic way to do it, but it's so much work, we're not going to do it that way. Competing products make it so easy to set up RAG, but AWS has made it overly complicated with their design here. But that's my complaints, but let's continue on. So we are going to knowledge bases, and we're going to create a new one. If you're worried about spend, do not launch this up. I noticed that when we had spun it up, and maybe this is because Bako spun it up, not me, but we had like an $80 spend here, $86 spend. So I think he turned it on and left it on for a few days with OpenSearch. Now you can use other things besides OpenSearch, which I've yet to try, but maybe that's something that we might want to do here. But notice here we have different options like S3 or a web crawler to grab information from the internet. I'm going to stick with S3, and that's where our data is going to go for now. So we will work with that. We'll go ahead and hit next. Actually, before we do that, we're going to need an S3 bucket. And I think I've already created one, but in case you don't know how to make a bucket, I'm just going to go ahead and delete mine and make a new one here. So I think I made this one here yesterday and I didn't do anything with it. I was really tired. I just decided to quit and carry on the next day, which is what is today. We'll go here and we'll make a new bucket. And yeah, I'll call it reg again, my reg, and just put some random numbers here on the end so I don't have any conflicts. You do the same. And so now we have our bucket. I'm just going to give this a hard refresh because these UIs do not update in real time and they get confused. So we have Amazon S3. We're going to go next. We're going to browse our source. We're going to go ahead and choose my reg. Okay, for this account, we're going to use default for chunking. Chunking is how you break up your document. And by the way, like we were using, was it the Bedrock SageMaker, Bedrock AWS workshops. And they have one here for reg. But I'm going to tell you right now, it is incomprehensible the amount of stuff that's going on in it. So yeah, under here we have reg, right? And there's some information here, like they're explaining what the pipelines look like. But I really do not like the way they implemented this code. They shoved a lot of the infrastructure into this utility, right? They should have wrote CloudFormation or CDK or something else to make it really easy. I mean, I suppose I could do that as well, but that's a lot of work. And for what we're doing here, it's not that important. But yeah, let's go ahead and try to figure this out the best we can. So I'm going to do Amazon Bedrock. We're going to drop this down. We have some options for KMS. And so we need to choose an embedding model. We're going to choose Titan Text Embeddings 2. I believe that's the one that they're using. They just say Titan, but I'm going to use 2, as that is the newer one. Embeddings are important because if you're going to use a vector store, you need to then convert the data into embeddings and to store it there. And then we have our vector database choices. So here we could use, we have OpenSearch Serverless. Then we have OpenSearch Serverless, Aurora, MongoDB Atlas, Pinecone, Redis, Enterprise Cloud, a bunch of options here. So I'm going to stick with OpenSearch, and so this will create it for us. We'll go ahead and hit next. And again, if you are worried about spend, do not start this up. I do not care if there's a free tier. I just had terrible spend with SageMaker Canvas, and I just know that in some of these areas, like I'll show you, this is SageMaker Canvas. I literally spent $349 in like 3 days because I forgot to close something. So, you know, just be careful here and maybe just watch for this one and see if we can even accomplish it. So we'll go ahead and create this knowledge base. It's going to take a little bit of time, and so we'll wait for OpenSearch Serverless to create. It does create a serverless instance, so we might want to go over to SageMaker, or sorry, OpenSearch here. Service. And it's kind of similar in the sense like Azure AI Search, which is the RAG version for Azure, also uses a search engine kind of in the same way. But I believe that it's going to show up under here. And so it was just showing an older one. I'm not sure why. We'll go back to our dashboard. And so we want to be very careful. Like I deleted the knowledge base, but it doesn't delete the serverless storage. I don't think this costs anything, so I'm not worried about it, but I'm going to go ahead, just because I had recent unexpected spend, I'm going to go ahead and delete this. Okay. So this one is now there. If we go back here, it's still creating. I'm not sure what it's doing, but we'll give it a moment to figure that out, okay? So I'm trying to remember how to use this thing, and normally the blogs are really good, but you go here and they really just get lazy here. They say, yeah, create it here, and then they just skip the entire middle part, which is a bit frustrating because, you know, I want to just get working with this as quickly as possible, but there's things that we need to configure like the index, and so that stuff is a little bit tricky. So let's go over to here, and this is now created. So we have our OpenSearch our open search index, but we're also going to need some files. And so I think what we can do, because there are files here in here, these ones here, right? I'm not sure what these are, but let's go ahead and open this up and see what it is. And these are PDFs, I believe. Okay, and so there's some kind of, I'm not sure what this is about. Okay, but it is Amazon and AWS related content. So what I'm going to do is I'm going to want to download these, and they're just the shareholder letters for AWS for the last 4 years. And so we'll download those. Okay, so just download each of those, and then we will, I'm just going to download them off screen here. Just give me a moment. All right, so I just downloaded them all to a folder there. And so let's just take a look at what they're doing. So download the data, and then here, yeah, they're just downloading them, then upload them to the bucket. And here they're just placing them into the root of the bucket. So we'll go into here, and then I'll just drag these on over. So we hit upload. Yeah, then we can drag them here. Let me just get a new window open here. I've downloaded them somewhere on my desktop. Just give me one moment. Here we go, and we'll drag them on over. Now, I think that they renamed the files. Before we do anything, let's just take a look at what they did. And so they renamed these. So I'm going to just go ahead and do that really quickly, because they, I don't think that the name has to match exactly, but you know, if we're going to do this, we might as well just do it exactly the same way and have less issues, right? Yeah, so that's 22. We have 2021. We have 2020. We have 2019. Okay, and so there we have our 4, and we're going to go over here. I'm going to upload. Oh, you know what I noticed? They have double PDF on there. I'll just take off those double .pdf extensions. You got to be really careful when copying and pasting. Always double, triple check as much as you can. There we go. And we'll go ahead and hit upload. And so we are now uploading those files there, and they are uploaded. Let's continue on and see what they're doing. So those files are now uploaded. So initialize open search service configuration, which includes the collection, the ARN, the index name, the vector field, the text field, the metadata. Initialize the chunking strategy. I mean, we already told it how we wanted to chunk. Initialize the S3 configuration, which will be used to create the data source object later. Initialize the Titan embeddings, which apparently that's already happened. So some of this has been configured already automatically for us. But let's go take a look at the open search service. And so they have collections. I think they had some mention here of a collection, right? So we'll click into this. Are we in collections right now? I think we are. Yep. And we would need an index, but it looks like it's already created an index for us. Okay. And we have a couple fields, so maybe that's chunking the fields, right? It's really hard without having to go through completely all of this, but just take a look here. We have, yeah, chunking. And the engine type is fast, and it's using Ulyssean, whatever. So these are things that we can choose as we are setting up these as we go here. Again, I'm just trying to visually try to map the information and try to figure it out. But here, obviously, we have our JSON object. So maybe what we're looking at here is that some of this information can be set up here, because it is saying the field, the vector field, right? And, you know, maybe some of that is here, right? If we hit add vector field, yeah, so we have those options, dimension, dot product, things like that. And again, just trying to match them up, right? So it's not exactly matching. That's totally fine. We'll continue on here. Okay. So yeah, this is whatever. Here we have our knowledge base. It's creating it. So this is doing it all through code. Again, they should do this through infrastructure. I'm not sure why they're doing it this way. Then they're getting the knowledge base. They're creating a data source, which is S3. We don't need to do that. It's already done that for us. It gets the data source. Ingestion job. So that sounds like a way for us to ingest data into our actual service, right? Or into OpenSearch. So somewhere here, there must be a way to do that. Or if it's not in here, then maybe it's in the knowledge base interface here. So if we click into this, is there a way for us to start an ingestion job? So let's click into this. It does not show it here. And we have like sync history. So I would imagine that would be like something that would have to do with the ingestion. If we edit this, what happens? Nothing. They could have made this clear, but you can see there's very few tutorials on how to do this. So let's just carefully look at the code and maybe we can figure it out ourselves. So here, ingestion job, data source. So here it's saying start the job based on the data source. Let's see, again, I'm trying to do this visually, but ingestion job. Knowledge base, AWS. Tutorial. Because all I want to know, if we can do this somewhere in the interface, and that's the reference information. So let's try the docs, knowledge base, AWS, docs. And maybe somewhere in here, they might give us some instructions. Okay, so we create that. Wow, this is hard to figure out. Give me a moment. I'm just going to kick around here till I can find something that's useful, okay? All right, so it definitely is this syncing thing. I think that's the ingestion job. And so it says here in Bedrock, left-hand pane, knowledge base, in the data source section, sync, right? So we're here, and we'll go to here, right? And then we have data source down below here, right? So you go here and then do that. All right, not the best interface. And so now what I imagine is that it's bringing in those files. Why they couldn't do that in their blog posts, I don't know why. But we'll give it a moment there to figure it out. I have no idea how long it would take. There's another thing that's going on here, which is the fact that there are PDF files. So those PDF files have to be converted, or there's a term, Azure likes to use it. It's Azure AI Search. It's one of their features. If you go to pricing here, I just remember it. And we call that, I probably have it in the slides here, but they call it, well, they're not showing it here. Azure AI Search. Maybe this product here. Oh, they changed the page on me, so I can't show you what it is, but it's basically extraction or conversion. There's a name for it, data crunching or something. And so what that means is like the PDF has to be parsed and then turned into text or format that we'll be able to store in here. And so that's just happening seamlessly for you. So I imagine there's probably other data types that we could use, maybe PowerPoint, maybe Word files, things like that. Not exactly sure. But did it finish syncing? It seems like it did. How do we know? I'm not really sure. Let's click into here. So I'm going to go ahead and see if we can start working with this. So configure retrieval and response to customize the search strategy for your knowledge base. Click that icon, this one here, I guess. All right, so we have some options here. Let's go ahead and select a model. And we'll just stick with Premier. Actually, I personally prefer Cohere, but we'll just stick with Premier here for a moment. So how many documents are available in our knowledge base? I don't expect it to know that because it's all chunked data. Let's see what happens. Now, a lot of RAGs, what they'll do is they'll show, source detailed information. And so it's showing us chunks, and it must be coming from that here, right? Yeah, and so you can see right now it's referencing that, and so we have now accomplished RAG, okay? I think that we can integrate RAG a few ways. Like if we were here to select a model, I mean, it's the same interface, it's just somewhere else. We go to Cohere here. I'm not sure if it would work with Cohere, but we'll try it. And yeah, I do not see the options here. I was hoping that we would see it. But maybe this is something that we would see more with agents. So like in agents, when you create an agent, and we'll look at this in a separate video, there is a way to attach a RAG. So yeah, I guess we're kind of done here for now. So I think what I'll do is I'll just delete this because I feel like we've accomplished our RAG. Well, first, before we move on, let's just take a look at what else we have here. So they have, this whole section's RAG. We have create documents, manage the knowledge base, retrieve, generate. So here, because with RAG, there's different ways that you can implement it, but I'm not sure if they're doing other RAG strategies. So we type in RAG strategies. I'm not sure which one will show it to us. But yeah, there's like all different ways that you can retrieve information. You know, like infinite combinations, because if you just remember what RAG is, it's just about getting external data from a data source, bringing it back, and then injecting it into the prompt or the context window before it returns a response, right? So, you know, a RAG could be going out to the internet and getting data. A RAG could be going to a vector search or vector store. A RAG could be going to an SQL relational database. It could be going to a document database. It could be going to a knowledge base. It could have all these strategies, how it works with the data before it brings it back. It could re-rank it, do all these things. So there's an infinite amount of patterns, and these are kind of supposed to represent that. They call it fully managed RAG, which is not very clear, but you know, I just want to know, is there something here that is of interest that we want to know? I don't think so. They're showing how to use it with LangChain. So LangChain is a great way to, and same with the Llama Index, a great way to set up RAG. But it's confusing because AWS kind of conflicts with these services by having their own agents and things like that. But I guess they always want to have their own variant. And so, you know, could be interesting going through a LangChain example, but what I've been finding with LangChain and also Llama Index is that the APIs right now are changing so much that I could try to use this code and it just probably won't work. So I'm not sure how well maintained this is and if we want to even bother going through this. Let's go to the top here and just take a look. Because if this one's already connecting to an existing one, it might not be so bad. So here we're installing LangChain. And then we are getting the Bedrock client, okay. And then we have this retrieve function. And here we're specifying the knowledge base. So you know what? Maybe we'll try this one. And it doesn't really matter. We could also do it with Claude. It doesn't really matter to me. Version 3. So this is just suggesting that it's an older one, but I think the process here is very similar. I wouldn't mind using Claude Haiku 3. So let's go ahead and try this one. And so we'll go over to SageMaker as per usual. Amazon SageMaker here. And Studio. And by the way, when you click Studio, it doesn't cost you any money to launch this thing, even though it's very similar to Canvas. And Canvas is such a terrible product anyway. It barely does anything of use. So we have this here. We're going to go to running instances. And you got to remember to turn these off. Like, I keep forgetting to turn these off, and that's kind of my own mistake there. But I'm going to go ahead and open this up, if I can here. It's because most of the videos I've been doing them back to back. So I'll go here. There we go. And we'll open that up. I'll probably make another video just to remind people to turn off these here, because I just do every video one after another, so I might not be turning them off. Okay, so we have this one open. We're going to make a new one for RAG, and we already set up our RAG, right? So we'll go here and make a new file or new notebook, and this one will be called RAG with Haiku. Okay. And so I'll bring that over here. And we'll go down here and we'll just start to bring things over. So it's using LangChain of a very specific version. And the reason why they're fixing a version is because I was saying earlier that it changes a lot and maybe they just didn't want to update their code. But, and this one's specifically locking to a specific version, but we'll go ahead and do that. Now, there's LangChain and there's LangChain AWS. And normally you'd have to install both, but they're only doing one. So I'm going to go ahead and give this a go and see if that works. Okay, and if we want, we can just restart our kernel really quickly here. So we go here and just say kernel, restart. And we'll see how far we can get through here. Here they're doing Boto 3, Boto Core. So you've been seeing me do this every single time. I don't know what the difference between the percentage and the exclamation mark is. Percentage versus exclamation in Jupyter Notebooks. What's the difference? Calls out to a shell in a new process while is associated with the notebook. So by itself has no lasting effect since the process change directory immediately terminates, changes the current directory of the notebook process, which is lasting. Okay. I don't understand how that would impact us, but that's fine. So I don't know what this store R is, but we'll go ahead and run that. Never seen that before. Yeah, what is store R? Okay. That could come in handy at one point. Restart the kernel. We did do that already. And so here we're going to do IPython. Again, if you're doing this locally, you'd have to install additional things. Now we're doing this again, and I think they're also doing this in SageMaker as well. So we're not going to have any problems running it here. And so we're going to do our imports. And we'll grab this part next. So I'm not sure why we're printing the session, but we can totally do that. Oh, we're just setting pretty print. Okay. And so we create a Boto 3 session. Again, not sure why we need to even do that. We have our region. Not sure why we have to do that either. So I'm just going to go ahead and take that out because we didn't do this for other ones, right? Just for setting this stuff up here. Let's just go here for a moment and take a look. Yeah, we literally just do this. So I would rather... Yeah, we'll just simplify it to be exactly that. We don't need this or this. And pretty print's fine, but I don't really need that right now. Until we need it, I'm just going to ignore it. We don't even need Boto Core here. We don't need pretty print, and I don't need JSON. Well, we'll leave JSON in. There's a high chance we'll be using that. So we'll go down here to the next step, and we have our... so we have our client. We're not doing any kind of chat. It's printing out the region, again, which I don't care about. Maybe they're doing that because if you're in the different region than your thing, then you'd have run into an issue, which is obvious. But we're doing everything in US East 1, so make sure that you're doing that as well. We'll change this over to client. So here, we're going to retrieve some text. I just like to clean this up so it's a little bit easier to read. Our retrieval configuration set up for number of results, which is up here, which is defaulted to 5. We have hybrid. We were passing our query, and then we have our knowledge base ID. So then it says, make sure you have your knowledge base. Okay, we already do. So what is Amazon doing in the field of generative AI? That kind of makes sense if we are hitting it up that way. Where is that knowledge base ID getting set? Nowhere. So here we have to go grab that value. I'm not sure if it's telling us explicitly about that, but it's very clear that we have to do that. So I'm going to make my way over to Bedrock. And I'm going to go here to knowledge base, wherever that is. All right, and so somewhere in here, there should be that. If we click into this, there's our knowledge base ID. So we're going to copy that knowledge base ID, bring it over here. And I'm just going to go and put it on a new line just so it's a bit easier to look at. So we'll just say KBID. I like how here it's like lowercase and then up here it's a different one. I'm not sure why they do that. So we have that. Yep, that makes sense. And so is that all we need, really? Let's go here and take a look. Initialize your knowledge base before querying. Yeah, we did that. And then that's their pretty print there. So I guess we could bring back pretty print. I, again, personally like it when these things are close together, so it's a little bit easier to see what's going on. So I'm going to bring this down to a new line. Right? And we'll just take this here and have that set there. And we'll run and see what we get, right? I think we already ran that. I'm going to just run it again. And we have an error. Bedrock runtime object has no attribute retrieve. Okay, so let's go ahead and look up Bedrock. Bodo 3. And so maybe it's changed since it's last used. Retrieve. Okay, we'll go back over to here for a second. Let's go back and take a look at this again. Because maybe there's something wrong here. So we have the client, right? And then you have Bedrock agent client. So we have an agent runtime and then a regular runtime. So we have a little bit of differences here. Now they do set all these things here. I don't care about that. So we'll go here and we'll set client, and then we have agent client. It's kind of interesting that it's doing it through the agent. It's almost like we are starting to work with the agent programmatically. I'm not sure. So we have this. And let's go back over to our code here. And so probably what's happening is that one is calling the agent. So this one is calling the agent for sure. Okay, so we go back to this one and we're going to copy it and we'll paste it in here. And so now we'll run this. Bedrock runtime has no attribute. Well, we changed it over to agent client, right? So that should be less of an issue. So we'll do this. This. Bedrock runtime has no attribute retrieve. Well, it's still saying client here, right? So I'm not sure what's going on here, but what I'm going to do is go ahead. It doesn't normally do that, but we'll go ahead and restart the kernel, and we'll just walk our way down here and try this again. Sometimes that's just how it goes, you know? You'll have to do things multiple times to get it to work properly. So we have client and agent client, right? And this clearly says agent client. We'll make sure this file is saved. We'll run this again. Right? And now we'll run this one. So here it says, calling the retrieve operation, not authorized to perform retrieve on resource to knowledge base because no identity policy allows the Bedrock retrieve action. Okay, so it sounds like maybe there's something we need to configure for that to work. So we'll go back over to knowledge base. And I wonder if there's like an identity or something attached to it. I don't know why the status, oh, it's ready there. And so there is a service role, right? If we click into this, I mean, we're able to retrieve here, so I don't know why we wouldn't be able to retrieve elsewhere. I like how these are all customer managed. And we have invoke the model, allow access, list the bucket. So give me a moment. I'm going to see if I can figure out where this error is coming from. Okay, so I'm asking O1 preview, which, by the way, has been really good at helping me out. And here it's suggesting that maybe it's the SageMaker execution role, which is the thing that would control the actual notebook. That makes sense because it has its own permissions, right? And maybe what we could do is find that. Now, does it actually list that out? It does right here. Okay, so that is really clear. So what we'll do is we'll just copy that name here, and we'll go over to roles. That was really nice to not have to stare at it for a long time and figure it out. So go here, and there's our role, and so we need to add some permissions here. The only thing I don't know, we'll add an inline policy here. The only thing I don't know is, like, can we just restart? Do we have to restart the for it to take effect? I don't know. So I'm just looking for ChatGPT. Here we go. And so it's suggesting this as their permissions. We don't really need a SID. We don't have to have a SID in here. And so here we are granting very specific access to retrieve for that knowledge base. We'll go ahead and hit next. And we'll just say knowledge base access. We'll create that policy. And so now our SageMaker notebook has access. Now, how would it reload that? I don't know. We can just try it again. I really don't think it's just going to take effect, but we'll try. Oh, it did. Okay. Wow, that's awesome. And so now we run it. And so now we're getting back JSON. It's printing it out. So you can see that it's talking about the customer reaction to what we've shared thus far, et cetera, et cetera. And it's referencing those documents. So there you go. We are utilizing RAG. So I'm just curious, what else do we have here? Because we achieved this. Here they're extracting out the text so that it's a little bit more clear. We can do that. I don't really care. But let's just do that really quickly. So we'll paste this in here, and then I'll just put it right after here because we don't need to have two cells for that. And we'll run this. Okay, and so same thing. We already kind of knew that we had that. And maybe what they're going to do is, yeah, that's what I thought was next. They're going to put it back into the prompt, because the idea is that when you grab things from your RAG, you want to load them back into your prompt so that they understand that context. And so since we're using, this is Haiku, we're using these XML tags so that we can tell, like, this is the context, this is the information that we pulled from our RAG, right? And then our question that we wrote is going to go here. So that seems pretty good. We'll go ahead and grab that. I want to consistently stick with the conventions they have here, like prompt data. And then we'll go down here. I mean, here it's talking about using Mistral. I thought this would have been for Haiku, right? But we'll take a look here. So I don't really want to use Mistral, so we'll just continue on here. Well, this actually uses it directly, right? But here they're going to use, oh, now we're down to LangChain. I didn't think we'd be using LangChain. Did we specify this up earlier? We did, right? Okay, so what we're seeing here is just like the normal way that you would call it, right? With the API, right? This is just like a normal way that you would use it with Bedrock. And so the next way is with, I don't think we need to run that because we've done enough prior. But this one is with the LangChain integration with Haiku, which is what I kind of prefer. I'm starting to get pretty good with LangChain, to be honest, because I've been building some little projects on the side here. And so we'll see if we can bring this in here. But normally what you would do for LangChain is you'd have to install a very specific type of intermediate package, right? So here it says, for example, replace imports for LangChain with base model 1. And so this might have to do with the compatibility versions of things here. I'm not sure. So I'm just carefully looking at this here. So what I don't know, like, if this is like an old, like if their API is not up to date with the latest one, but we'll carefully read here. So so it says here, as of LangChain core, LangChain uses Pydantic version 2 internally. Was a compatibility of 1 and should no longer be used. Please update the code to import Pydantic directly. Okay, so what I'm going to do, type in LangChain Bedrock example because maybe the LangChain one has a more up-to-date version. They're pretty good about that. You're currently on a page documenting Amazon Bedrock text completion. And it depends if we want chat completion. And technically that's what we do want is chat completion. But I'm specifically interested in this part. The knowledge base. Let's go back here and take a look here again. So yeah, I'm not sure. We'll just have to go ahead and ask ChatGPT here and see if it can just figure it out for us. It'd be really nice if it can. I'm not sure if it can figure it out, but we'll give it a go and see what happens. All right, so yeah, it was saying maybe replace this with Pydantic because it's using it directly now. It seems like we'd also have to install Pydantic. But we're not using the model here per se. Yeah, and so it's making me think that what's happening here is that maybe internally AWS is not, their code is not up to date. And so that's why they're using a fixed version. If your code relies on Pydantic v1 features, use this instead. But that's not going to help us here, right? So, yeah, I'm not sure if we can even finish this. I mean, again, we could go fix it to the older version, but personally, I use Llama Index. I don't use LangChain. And if it's not going to work here, I don't think it's worth our time. But let's just take a look and see what it does. So here we are bringing in the chat conversation, right? We define it like this is, you know how we do the Bedrock client? It's a very similar process where it creates a client. And then here we have the retriever, which is like the function that we kind of created, but it's already here. And then you call the retriever through the API and it does something very similar. And then you are injecting it a very similar way. So yeah, nothing too complicated. But the nice thing with this is like, it's very easy to have a continuous conversation going on with LangChain, whereas you'd have to make an additional function here with Bedrock to have a continuous conversation. But let's go back here and take a look and actually just finish this off maybe with the Bedrock version because we know that one's going to work because we've done it so many times. Even though it's not that exciting, let's go ahead and do it anyway. So we did this prompt here, and so we'll grab this, and I guess I'll use Minstrel. I didn't really want to use Minstrel, but that's totally fine. And so, and again, you know, if you're worried about spend, just don't do anything. Just watch, okay? So we'll go ahead and run this here. Prompt data is not defined. It is not ran. That's why. Okay, that's fair enough. And we'll do this one. We'll go down below and I don't like this mess of code. We're just going to go ahead and grab our another one, like maybe from Zero Shot here. I'm sure we have a bunch of nice formatted code somewhere here, like this one here. Yep. So we'll grab this and we'll just change it out to be what we want. So we want, I guess, Minstrel here. And the rest can be taken out. The body's here, so we'll just get the payload here like this. Like that. And I mean, we could just literally paste it in here in one go, and it's a bit nicer here. We don't have to have two separate things. Okay, and so we'll just run that. That should work. There we go. And as per usual, we'll go ahead and grab our code down below. And we'll run this. And we'll run this. We could put it as one line. I don't know why we don't. The body might be a little bit different here because we're using Minstrel. I'm not exactly sure what it returns back, but let's go ahead and do this. And so here it is going to be output. Looks the same as before. 0. And then we have text, right? It's the same. Okay, what was the problem? Outputs. It's outputs. Okay. There we go. So Amazon is investing substantially in large language models, et cetera, et cetera. So there, we have accomplished RAG. And yeah, there are other ones here, but they're basically just derivatives, and they're not. This is quite the mess of a lab. Okay, so we'll consider this one done, and I'm going to go ahead and download this RAG example here. We'll download that, and we'll go over to GitHub, AWS examples. That's Azure examples. Don't have a whole lot there. I have to really get back on all the Azure code here. We'll go ahead and hit period here, and I'll make a new folder in Bedrock here, and that. And again, you know, if you just don't want to go through all this code, I tell you at the end of the videos, it's kind of useless, but you know, if you want to save yourself some time and you know, you don't need to know this in depth or implement it directly, then you can just run it and have confidence that this code at least works, and then pass it on to a teammate if they're just trying to implement this stuff. So I'm going to go ahead and I'll directly upload this. Give me a moment. All right, let's take a look here at agents. So Amazon Agent Builder provides a low-code, no-code experience to create agentic workflows. It features things like choosing from multiple foundational models, adding guardrails, adding knowledge bases, adding tool use, adding session management, adding a code execution environment, which to me is really cool, but I haven't been able to figure out how to do that yet. And so here on the right-hand side, this is specifically is for the tool use. It's supposed to be pointing right here. I'm not sure why it's a little bit off. But the idea is that you define these functions. So you say create booking, right? And then you give it a description and then parameters. And this is going to go to a Lambda function. But the idea is that, let's say you're building, and we do this. We build the restaurant app and we say, we'd like to book a reservation. And it can figure out, oh, you want to, based on the description and the name, you want to create a booking. So let's invoke that Lambda. And that Lambda will go out and then insert it into the DynamoDB database and return the data back. And then it will tell you, oh, this is your booking with this information. So the point is, the key thing here is that it's an agentic workflow. That means the agent has its own agency. It can do things without being explicitly told to do them. So if it needs to go to the knowledge base to go find information about the menus, it will contextually do that. If it needs to trigger a function like tool use, or so that it can insert something into a database or do something else, it absolutely can do that. And this is different from using something like LangChain or Llama Index or a prompt flow where you're explicitly defining the pipes and the routes. Think like a state machine, think like step functions or things like that. And so this is very useful, but it only does those two things really, like the tool use and the knowledge base, well, three, like the code interpreter. So it's really just those three things at this point in time that it can do. Some other things I didn't write in here. I don't know why I didn't do that, but one thing you can do is you can get traces and see exactly what the agent is doing. So like, how did it reason that it had to go out and go do the tool use? Or how did it have to go and decide to pull something from the knowledge base? So you will see that when we work with the agent. And I didn't say this in the, I don't know why I didn't say this in the knowledge base, but in the knowledge base, it actually tells you the referenced materials that are coming back. But anyway, you'll see that in the hands-on lab. So I know the slide here is a bit light, but I did a good job with the lab. So I'll see you in that, okay? All right, so in this video, we're continuing on with our agent. We have yet to delete it. We have yet to delete our knowledge base. So we have a lot kicking around here. And in the last video, we did just set this up here. I was trying to figure out why is this not part of agents? It seems like it should be, but maybe there's two separate teams working on two separate things, and that's why we have some overlapping features, but obviously the agents are in there. Because the thing is, like, when you're using prompt flow, you can set up conditional nodes, right? And from there, you could call a Lambda function, which is basically the same thing as tool use. And so this is where it gets a little bit confusing. But I guess the idea is that there are agents that have agentic workflows or agentic coding. They have agency to go do things. And then there's workflows where this will literally just pass it to the next thing, and then you have to interpret it, or the next agent interprets it, right? So let's get this started and see what we can do. So here we have a flow input, which is our document. And I imagine that that's going to be our inputted information, and then we're going to want to place this into the input text here. Now there's prompt attributes. I'm not sure what we want to set here. There's also session attributes. But for now, I'm not really worried about that. And so the idea is that we might want this to flow out as the response here. And so this would be the most simple example of this here. It says here has been added to your nodes, etc., etc. So I'm not exactly sure what it's saying there. And it's saying must satisfy regular expression. Again, not sure if that's actual real problem here. One valid error detected. Agent alias ARN failed to satisfy constraints. Okay. And I guess the thing is, like, I guess I didn't set one here and just say, restaurant agent, like that. And then we also have to drop down here, I guess, select its alias. And it looks like we have, our string here and our inputs. So I'm going to leave this stuff alone as, so we have the input text here and just saying, like, what is it mapping to? Okay, that makes sense. So we'll go ahead and save that. And so now it should save. Good. And I think there's a way that we can test this because it looked like, here it is on the right-hand side. We can go test our flow. So what do you have for the adult menu? And so this will go out and hit the knowledge base and all the other stuff here, right? But let's see how this works. It'd be cool if it highlighted as it went. I'm not sure if it'll do that. Again, this is in a preview state, so that's kind of suggesting that it could be broken. So the adult menu at this restaurant includes the following items. Great, and so that worked out perfectly fine. So now imagine we want to do something here. Maybe we want to modify it before it goes to the end here. And so here we do have Lex. Lex isn't that speech? Amazon Lex. Oh, it's a conversational chatbot. Okay, so imagine that like Lex could be used to say like that could be for basic Q&A, and so that could be utilized for that. And so maybe you would want to query that database if you already had it. But I'm just trying to think of like what we could do here. We could try to add another agent. It's not like, oh, we have prompts. Maybe that's just like an LLM. Let's see if we drag that out. What do we get here? Prompt, it depends. What the heck is that? Oh, that's from prompt management. Okay, so let's go over to prompt management for a moment. We haven't really used it yet. And so this prompt from prompt management, the way it works is it's a prompt that the idea is that it always summarizes a conversation as it depends and is not cooperative. So that's something that is in that over there. So that's kind of interesting. I'm not sure how I would utilize this here, to be honest, because I guess that would be an existing prompt template. Okay, so I guess, we could try to use this. So let's go create a prompt template. And I want to go ahead and just disconnect this here. And in here, we might want to bring our input into this. But for that to work, we need to go and change this. So I'm going to go over to our prompt management here. I'm going to make a new one called restaurant. I can't spell restaurant, obviously. We're not trying to do anything serious here. We're just trying to utilize prompt flow to do anything, restaurant customer prompt. And we'll go ahead and create this here. And so the idea is that we have test variables down below. And I would think that there'd be some way, so like, what is on the blank menu? Right? And the idea is that we have topic down below here. I'm going to go ahead and save this, save draft. We'll create version. It'll be version 1. And so now I'm going to go down back over to our agent, wherever that is. We already had it open here. I guess we closed it, so we'll click back into it. And we'll edit this. And so what I want to do is now try to bring in that node. So bring in prompts. And we'll say this one here with this version. No associated model is associated with the prompt. Select a model to generate a response. Oh, okay. So I was thinking that this would just be a way of modifying your prompt before you pass it along. But here it's suggesting that you'd actually have to supply a model. Okay, so that's not exactly what I was expecting. But you see the input is the topic. And so I was thinking like what you do is you'd go here first. You click off on here, right? Can this be? Yep, there we go. And then you'd go into here first and then go into here, right? But here it's expecting a model. So I'm wondering if we could just save that and not associate it with a with one here, because all I wanted to do is pass along. So if here I say children or adult or dinner, let's say dinner. Doesn't include a model. Okay, so that's not how I thought the prompt manager would work, but that's totally fine. So what we'll do is we won't use it in this part because it doesn't really make sense to do that, right? So I'm going to go ahead here, and I thought like we could just use it as a means to modify our template, but that's not the case. So let's go back over to our prompt management, and I'm going to go edit this one here. We'll delete this prompt actually. We'll say confirm delete. And I'm going to go make a new one and just say restaurant prompt format. And we'll just say here, take the following content and format it into a bulleted list. Okay, and then we'll select a model and we'll choose something like haiku. And that one can do that there. I don't need to run it. It's pretty straightforward what it's doing here. We'll create a version here. And then we'll go back over to prompt flows. We'll click into here. And we'll edit this here. And so instead of having this here, we'll actually edit our output. So we'll zoom in. Right? And we'll just take this out here like that one. It's very hard to get these out. There we go. And so what I'll do is string this to here instead. And we'll bring this over here. And so now we'll go here to here. And then this one will go here to here. Okay? So now we have this kind of flow here, which is totally fine. We're going to go ahead and save this. I'm not sure if it's saved, but let's go ahead and test this. So let's say, I want to know what is on the dinner menu. Let's see if it can do that. Oh, you know, we probably didn't configure this properly. Let's go back over to here. This one is using this one. There we go. And this uses version 1. That's going to fix that problem there. We'll save. And that's saved. Okay, we'll give it a moment. Based on the search results, the following is included in the following. And so it looks like it's doing what we asked it to do. And what's interesting is like we have this here. It seems like we can almost modify. Can we? No, we can't. Though it makes it a text box, which is really confusing. I don't know why they do that. I did not want to get rid of that. Let's go back to here. We already saved the prompt flow, so I'll just click back. And we'll click back into our prompt flow here, and I'll go back to prompt manager. And what we'll do here is go back into this one, and we'll edit this prompt. Okay, and we'll say, take the following content and format into a bullet list, but maybe we want to do something else like take the following content and summarize to use the least amount of words. As HTML. or as XML. Okay, so we'll go ahead and do that, and we will create a version of that. And so hopefully this is version 2. Let's compare our variants. I was thinking like versions, actually, never mind. But anyway, we'll go back over to prompt flows. Prompt flows here. And we'll edit this here. And so this should be the same thing. So what is on the dinner menu? It should just know that it's changed. Actually, it wouldn't, because we'd have to change this to version 2. And we'll save that. And so now we'll run this. What's cool is that you could have multiple versions and maybe you just like bridge between them. Okay, it'd be nice if it showed us it updating in real time, but it doesn't do that. And so now we're getting back XML because that's what we asked it to do, right? It's doing a very good job of it. We have, what is this, a collector? What is that? Collects data from an iterator node to create and transform an array of items in a map loop. Okay, so it seems like it can collect multiple data. And then we have a condition and an iterator. So I'm not exactly sure what we'd want to use those for right now. I'm also not sure how we delete nodes. There's one. But like, could we set up a conditional? So condition. How do we tell it what the condition is? Oh, so literally would it just be number, string, false? So if the condition is false or true or number like 1, 2, 3, or 4, then it could route it. So I guess like the way this would work is that it would have to, you'd have to tell the prompt to only return a single value, right? That's the only way this would work, right? You'd have to say, give it this particular format, and then it would go out, and then maybe you could do that. So yeah, you kind of get the idea of how this works. It's not that confusing in terms of how this would integrate. Yeah, it's fine. I mean, it just depends on what you want to do. But yeah, that's prompt flow for you there. I think we are done with prompt flow. The only other interesting thing would be like testing out prompt manager, but it seems like you can only have one output. Can you have, oh, you can have more than one. Okay. Well, how would that work if you had more than one output? That's what I would like to know. So maybe what we could do here is, so maybe we could like split this off into multiple ones. It's iterator. Yeah, and so that's a curious question. Like, could you have more than one output? I don't know. And if you did, like, how would that even work? Because like you open this up, how would it represent those two? So this would take a lot more work to play around with, but you get the idea of it. And so we're going to consider this done. In the next video, we're going to do a cleanup video, and then we'll get back to our normal stuff here. But yeah, this is prompt flow, and I guess we can just clean it up now. It doesn't really hurt to do that. So we'll go ahead and delete this. And I'm going to go back over into my prompt manager here. We'll just go ahead and delete any prompts we have. I don't think they cost anything, at least at this point. In the future, they might, because it's still in preview, right? Okay, and I will see you in the next one, which is just a cleanup video. Hey, this is Andrew Brown. We are back, and I just wanted to do some cleanup as we left a lot of things running here, like a knowledge base and other things. So let's go ahead and just start deleting things. So the first thing we want to do is delete our knowledge base. That is something we'll have to delete. Another thing is we have a DynamoDB table that we have sitting around, so let's go ahead and delete that. This is the big cleanup from when we did whatever. What I said that we were going to clean up from earlier, so we'll go ahead and confirm and delete this. Delete all cloud. We do not want to do a backup. So that is now deleting. There was that. We also have an S3 bucket that we don't need anymore, so we'll go ahead and get rid of that. So this is here, my rag. So we'll go ahead and just delete these quickly. And we'll say permanently delete. And I'm going to go back over to here, to buckets. I'm going to go ahead and delete this bucket now. So there was that. We created an agent. We want to get rid of that. So we'll go over to Bedrock and get rid of that. So we'll go over to agents here. And we'll delete this and say delete. So that is now gone. I'm not sure if this is gone, but we need to get rid of OpenSearch here. So let's go get rid of that. OpenSearch service. And we'll go to here to the left-hand side, and we'll go into serverless. That's what it is. It's not anything else. So we'll go ahead and do that. Confirm. So that is now gone. The other thing that is running that you may want to shut down is if you go to Jupyter and you go Jupyter Studio, like go back to SageMaker here. If you go here to the left-hand side into Studio and then launch it, right? That's just going to open up this. We go into Jupyter Lab here and we have this running. If you want, you can stop it. In the next video, I have to carry on because we're still doing things. We're doing fine-tuning and other things like that. Just a couple more things. And so I want to keep that around because fine-tuning, I think that we might use this space. So, well, we can just go find out really quickly because if we go here to the fine-tuning examples, yeah, we have notebooks. So we are going to do some fine-tuning here. So I'm not going to shut that down. But for the most part, we have cleaned up our agent and our RAG and anything else. And so, yeah, I'll see you in the next one. Okay, ciao. Let's talk about Prompt Manager, or also known as Amazon Bedrock Prompt Management. This allows you to create reusable prompt templates with variable injection and create multiple variants of a prompt to quickly test and fine-tune your prompt engineering. The reason this is useful is that imagine that you want to test this prompt template against 3 or 4 different types of LLMs, or you want to quickly create variants and test the variants against each other. So I could see this being really useful for testing. Azure AI Studio has something very similar where you're doing bulk tests. The bulk part is kind of missing from this. So that's the thing I would think that they might get down the road. But right now it's like, it's hard to do like, let's say 100 and iterate through this to create an evaluation test set or like a output test set to see if things worked out correctly. So there's a lot of plumbing you have to do to get that to work. This thing is integrated with Amazon Bedrock Prompt Flow. It's a bit unusual because in Prompt Flow, and we'll see this in the hands-on lab when we do Prompt Flow, that I would have thought the way it would have worked is that it's like if you want to just have a prompt and then tie it to an agent or an LLM, but when you drag it into Prompt Flow, what happens is that you have to choose an LLM with it. So basically, it is the LLM as a component. And then you have to have a prompt template with it. It's a bizarre design choice, but you'll see that when we check out that section. But this stuff is very straightforward. You make variables and you insert the information you want, and that's going to go into your prompt here. So here I have a generic one where it's like, this is the kind of prompt template that I always like to have, which I'm like, role, profession, instructions, response format. And the idea is you can then create variants of the data and then quickly test them, okay? So Amazon Bedrock allows you to have custom models through training. And so you can choose a foundational model. So like one of the models from the catalog, not all of them, but a lot of them allow you to be trained. And you can do either continued pre-training. Sometimes they call this continuous pre-training. So it just depends on the documentation, but it's the same thing here where you're using unlabeled data that improves the model's general knowledge. Then you have fine-tuning where you're using labeled data that improves the model to perform a very specific task. So make sure you understand those clear different things. But yeah, continued pre-training is you're just adding knowledge, like just general text, just tons of text, and fine-tuning, trying to get them to do something very specific. And the format of those files, and by the way, those are JSON-L files, which is JSON object per line. It's going to vary based on what you want it to do. So if you're doing text-to-text, then I think that's the format there, prompt to completion. If you're doing single-turn or multi-turn, then the format will vary for the fine-tuning options. You can use SageMaker Ground Truth to create and label training data sets. But I mean, it's not that hard to label your data, but it depends on how much data you have. There's also other things you might want to know, like about the cost. So imagine if you have a custom model, like let's say use Cohere Command. We're using this as pricing example. You have the training time. So if the price to train is 1,000 tokens, you're paying at 0.004 cents. If you'll need to store the model. So there's going to be an additional cost per month for that. And when you have a custom model, you have to use provision throughput. So if the model previously was on demand, now it's going to be provision throughput. And so that's going to be 49.50 per MU in this case here. So it's going to vary based on the model you're fine tuning. Okay. So when you deploy a custom model, you have to use provision throughput. So factor in the continuous cost versus the on-demand costs for having a more intelligent model. Okay. Let's talk about import models, which is related to custom models. This allows you to import model weights, allowing you to bring specific models as custom models that you can allow Amazon Bedrock to deploy and manage. And so there are some things you need to know about the infrastructure or architecture. It only supports Mistral, Flan, Llama 2, Llama 3 right now. I'm sure they'll expand it in the future. When you import a model, you provide the following files that Hugging Transformer Library creates. So you have safe tensors, config JSON, tokenizer file. I think it's supposed to be JSON. It's not Sun, it's JSON. We have a tokenizer file, tokenizer.model. Importing models is useful when you have trained these specific LLMs outside of Bedrock on your own compute or within SageMaker. So it gives you more flexibility because when you use the method training for custom models, you're doing whatever AWS lets you do. So this gives you more flexibility as long as it's compatible, okay? So Amazon Bedrock Guardrails allows you to filter inputs and outputs for LLMs. And so here's an example where I created a guardrail and I wouldn't let it talk about Microsoft Azure or bananas. And I told it that when it encounters those, it's going to reply back and sorry, the guardrail has said that it's not allowed to be said. So what kind of guardrails can we put in here? Well, we have content filters. So this will be based on harmful category filters from 0 to 5 or something. You have prompt attack filters, which are for people trying to do injection or try to break into the logic of your LLM model to make it do things it shouldn't do. We have grounding filters. So this is a score threshold to validate if information in reference source is grounded and factually correct. So you'd have to provide a reference source when doing it. We have relevance filters, so validate if the model's response are relevant to the user's queries. We have deny topic filters, so describe a topic to the LLM that you want to block as the input. So maybe saying, don't start a sentence with the word don't. You can have up to 30 defined topic filters. You can provide 5 sample phrases of 100 characters alongside the description. You can filter out profanity. You can filter out specific words or phrases. You have PPI or PII filters, so up to 31 PII types, where you can either say block or mask. You can do reg expressions up to 10. There's another service called Amazon Bedrock Watermark Detection, which detects if an image was generated with Titan image generator model. It falls under this guardrail section. I just didn't want to make a slide for it. It's not that interesting for us to produce a slide or a video on, so I just threw it in there. But yeah, guardrails is something you can integrate with the LLMs right in the playground within Amazon Bedrock Agent. I'm not sure how you do it programmatically if you weren't using an agent, but there might be a way to do it, but it's pretty straightforward. If you're using a framework like LangChain or Llama Index, they have guardrails that you can do, and it doesn't cost you anything. And so, again, that's another reason why you might want to use LangChain or Llama Index instead of paying that huge cloud cost for this stuff, okay? Hey everyone, this is Andrew Brown. In this video, we want to take a look at guardrails. So guardrails is a way to keep you safe by allowing you to pre or post filter your information. Before we use this, let's go take a look at what the price is here. So if we can even find it here. So we'll say Amazon Bedrock Guardrails. Okay. And I guess I should type pricing so we know what it is, because it must cost something. Hopefully it's not super expensive. I really do not like the pricing here. They've gotten kind of worse about showing pricing information. So we have content filters are 75 cents, whatever, denied topics. Sensitive information is free, word filters is free. So we have some examples where we can filter some stuff. Let's go ahead and set up a filter. And we'll walk through this. We're not going to do everything. And of course, if you don't want to have any spend, you can just watch me do this. I'm going to just say my cool filter, and we'll go through here and see what we can do. So messaging for block prompts. So enter a message to display if guardrails blocks the prompt. So sorry, you have been blocked by the guardrails. Just so that we explicitly know. Apply the same block message for all responses. Sounds good to me. We have harmful categories. So enable to detect and block harmful user input and model responses let's take a look what we have here. So we have these. We'll set it all to high for now. We have prompt attacks. I'm not going to do that here right now, as that would take some work to figure out. We have denied topics. Let's see what we can do for this. So valid characters, don't talk about Azure. So here, example, talking about Azure, Microsoft Azure services is not allowed. We only want to discuss AWS cloud offerings. Okay, so there we have this. Okay, we'll go next. Profanity filter. I don't want to swear because it's not, my videos go for free, so I don't want to do that. So we'll ignore that. We have some custom word and phrases. That's a good idea. Let's go ahead and add one. So we'll add a word or phrase, and the word will be banana. Okay, so, oops. And I really dislike their interface here. It's not the best. Just checking my time here, because this shouldn't take too long to figure out, but we are not going to allow the word banana. It's not clear whether it's not allowed or if it is allowed. Add word filters. I'm going to assume filters to block certain words. Okay, so banana is not allowed. We have personal identifiable information. So here you can add different types. So here we could say add all, which are all of these. So we say mask, mask, mask. You could block it. So mask, mask, block. But here it'd be kind of difficult because there's no chance for us to actually see this information unless we have data that it's pulling from and returning. And then there's regex. So we could just say nothing that starts with red. And so we go here and say // red, $. We'll just say block and confirm, next. So you can see I have a lot of stuff going on here. It doesn't like something maybe. What's wrong? It doesn't seem to like something. And so that's one thing I do not like about, maybe we'll just take some of these out. We don't need all of them, to be honest. So maybe we'll just take this out here. I'm just trying to figure out why it's not working. There we go. And so how do we hit next now? There we go. So it didn't like something that was set. We have the ability to check for grounding. That's a ground score and relevance score. So that's kind of evaluations. And if it doesn't meet those things, then it will come back here. We'll go ahead and create guardrails. So it's going to be hard to test all of these, but here we can test it right away. We'll go over to Co here, and we'll say, we'll go to Command R+, and I'm going to go ahead and, for contextual grounding, check the option. Oh, so we provide some contextual referencing. I don't have any for now. I didn't think we'd have to do that. We have our prompt, and then we have our model response. So let's go ahead here. Tell me about Azure and bananas. Azure's cloud offerings and bananas. And we'll go ahead and run this and see what happens. Give it a moment. It's really thinking here. I'll just pause here till we get our answer. And so here you can see, sure, I'd be happy to explain Azure's cloud offerings. And here it says down below, sorry, you've been blocked. So it's obviously detected those issues there. And that's pretty straightforward. So that's all we have to really show for guardrails. Guardrails can be attached to your agents, to your LLMs, et cetera, et cetera. So it's pretty darn straightforward. But I'll see you in the next one, okay? Ciao. So Amazon Bedrock allows you to do model evaluation through their model evaluation feature. It has 3 modes: automatic, bring your own team, AWS manage work team. And if you're going to choose automatic, which is most likely what you're going to utilize, you have these 4 options. It's going to be able to produce a variety of metrics, at least accuracy, toxicity, and robustness. Probably 4, because I believe that this is based off of the model evaluation library that AWS has open source, which we take a look at in the hands-on lab. I did do the hands-on lab, but what I found going through that process was that the data set they provided, because when you go through the process, they'll give you a sample data set, is really, really large. And so unless you curate your own data set, which I didn't do, I feel like this could get really expensive very quickly. One thing I noticed is that you had to enable cores on the S3 bucket. You had to also grant additional permissions. The UI was really, really janky and not working correctly. So I could get it to run, but I don't feel like this is the best way to evaluate your models. I feel like this service is not well developed. and you could just use an open source library instead. So I just wanted to make that clear. That's why these slides are so light, because I just don't really want to recommend this this feature, but I will show it to you. But just watch the lab. Don't actually do it, because I end up turning it off. But at least it gives you an idea of how it should work, okay? Hey, this is Andrew Brown. In this video, I want to take a look at model evaluation. So in Amazon Bedrock, over here, we have model evaluations. We did see an open source library. I can't remember what it's called. It's called like Amazon Evaluation Model GitHub. Let's just see if we can find it. Yeah, FM Eval. And so I have a strong feeling that this is what this is utilizing underneath, because a lot of these things seem very similar. I've never used this tool before, but I'm sure it's pretty straightforward. But we do have three options here: automatic, bring your own team, AWS manage work team. There's a name for this. It's like RFHL learning. Is that what it's called? Reinforcement learning, human feedback. But that's for learning per se, and this is more for evaluation. So it seems like here you'd have to manually check that over. So I'm not exactly sure that process, but let's go take a look at automatic evaluation. So I'm going to go here and just say my gen. And what we're going to need to do is go ahead and use a model. So let's say I want to use Cohere Command Lite. And so we have a few different ones like text classification. Let's go ahead and do that. And so we have some metrics. And so here they have some built-in data sets. That means that they're already providing you the data to input and to check against. And then it's going to determine based on that how accurate it is. Same thing with robustness for this. Obviously, different categories, you're going to get different metrics that you can work with. And so we're going to need a bucket. I did just create a bucket. And so I'm sure you know how to create a bucket at this point, but it's very simple. Just name a bucket, whatever you want. But one thing I'll need to do is I'll need to open up cores, because I'm pretty sure when I tried to save this, it was giving me a little bit of trouble. And this browse button never works. So I just go here and do this. And I think what it wants is you do /output and end with a / or it will error out. Again, I was just doing this so a little bit, so I know somewhat what's going on here. And so here it doesn't like the name. Valid characters are whatever. Okay, let's try my gen eval. Let's try this. And then here, see, it says does not have cores. So let's open this up here. And it's asking for something very specific. Get out of here, Amazon Q. And so we're typing in cores. And it didn't point us to anywhere. So that was not very helpful. So what cores settings does my AWS bucket need to have to work with Amazon Bedrock? Model valuation. And because I just don't know what it's going to be for that, I'm just trying to make my life a lot easier if it could tell me. But let's go over to where cores is. Maybe it's under properties. I always kind of forget. And it is probably permissions, because it is a permissions kind of thing. Cores. Here's cores. There we go. So we can edit our cores here. And we'll go back over to here and see what it said. Require permissions for model evaluation with Amazon Bedrock. Maybe. Okay, so here we go. So you create a model. You must specify the correct course permissions. To learn more, go here. And so allow from everywhere. That sounds terrible, but okay. Normally you would say like what the origin is, but literally that's just like wildcard everything. You don't usually do wildcard everything, but they don't have anything else here. Required console permissions to, no, we're not doing human. For automatic. So the following policy contains the set IAM policies. It's giving full access, so it looks like that doesn't really matter here. So we'll save that. And again, it seems like the allowed origin should be more locked down, but whatever. If AWS is giving us that, then we can't complain too much. And I'm going to go ahead here and hit create. Or we'll select an existing role. It's having a bit of a problem here. And we have a lot of roles that we're creating here. I don't know what this role was going to be called. Let's go back here. This would be AWS IAM role. So I'm going to go ahead and copy this. And we'll search for this. It's crazy that sometimes it has the search and other times it doesn't. And even if we had the search, it doesn't really work, does it? Yeah, this UI is just terrible. You know, it just doesn't work as expected, which is kind of frustrating. So I'm just going to change the numbers here. Maybe the problem is it's conflicting with the numbers. And so we'll try this again. No errors. Does not make it clear as to what's wrong. My eval. Can we try this? Create. Create. And so I can't seem to create this. So we'll try this again. Why it will not work, I do not know why. We'll zoom out here so it's a little bit easier. We'll try this again. So my gen eval. We'll select our model, go here. Command R or Command Light. I'm going to go with text classification. We're going to go grab our bucket here, which is this one here. We're going to go ahead and type in S3:// outputs. And we'll scroll on down. Everything seems fine here. It's going to create this one, hit create. Select an existing role or create a new one. I would love to create a new one. Just let me make it. So choose an IAM role that grants Bedrock permission to the S3 bucket. So what I'll do is I'll go ahead and grab this one because it's just not working as expected. This one has S3 and this stuff here. So I'm going to copy this because obviously their UI is just as garbage. It was always saying they care about the developer experience, yet they ship garbage. There's no nice way to say it. Like they're not doing a good job here with me anyway. It's been years, AWS. Come on, get your acting gear here. Okay, so let's go ahead and paste that in. We'll go ahead and hit next, and we'll just say Bedrock eval eval role or policy. And I'll go ahead and save that policy. We'll go over to our roles. We'll have to create a role now. This will be for Bedrock, I guess. Bedrock. I don't know, so I'll have to make it a custom one here. The only thing I don't know is like, what would we assume the role as for this? I don't want to lose this just yet, so I'm just going to paste that up here really quickly. Let's go back over to here. Okay. And so what I don't know is what kind of role do I have to assume? So I don't know. I'm going to go ask ChatGPT. I need to create permissions in order to access. I need to create permissions. I need to create an IAM role and policy for Amazon Bedrock evaluations to access an S3 bucket and just have general permissions it expects. Okay, because I don't know what I need to make as the assume role as the principal. I'm assuming it's Amazon Bedrock, but I'm not 100% certain here. And so this doesn't necessarily mean that this will be correct, but at least it will take a guess. I meant to choose O-Mini, but whatever, that's fine as well. So, I'm just kind of ignoring all this because we already have that. But what I'm looking for is, let's just go ask him so I just need to know what to do for the principal. What is this called? For the trusted policy? For the trust policy. I'm going to assume it's Bedrock. I just don't know what Bedrock's trusted policy is. Like our principal here. Okay, so it's just that. So I'll go ahead and grab this quickly. And it's not exactly what I wanted. And we'll go ahead and hit next. And so now what I need is this policy here, which apparently is gone now. Just type in Bedrock here. We know this is a customer managed one, so we'll go ahead and do that. There it is, right down there. We'll go ahead and hit next. This would be Bedrock eval policy role. And so I'm going to go here and choose an existing role. And so hopefully I can select it. And we don't have it. So I'm going to again have to refresh this because they have a terrible, terrible, terrible UI. I'll never be nice to AWS about their UI. They change it and they still make it suck. Okay. We'll go here and we'll go down to this one. We'll go to text classification. I'm going to go and use an existing role right now as it sucks and can't seem to select anything. And there it is. I'm going to go back over to our S3 bucket. And we'll go ahead and type this in here. And so we have those set. Nothing else that we need to do. Let's go ahead and create this. Hopefully it works now. Did I not just select the role? Eval role. Whoops. There was an error. Bedrock does not have permission to call. Please review your Bedrock IAM policy. Okay, well, I don't care. We can change it to Amazon Titan if that makes it happier. Well, that's just only light and express, so it's not exactly what I wanted. Let's try Haiku instead, maybe. And we'll have to try this again. We'll go ahead and hit create. Create an IAM role service that grants permission to the S3 bucket in your evaluation model and the models you selected. Okay. So now I need to know, how do I give it access to the models? I'm going to choose, again, mini. This one's faster. So I need to know, let's go make a new window here. I need to add permissions to access command like cohere model in for a role that is used by Amazon Bedrock. Okay, hopefully it can figure that out from the lack of information I've provided here. It's going to do 100 steps. And so here, yeah, maybe it's this. So we're going to go ahead and grab these parts here. And we're going to go back and find our role. We're actually our policy per se. And we'll type in eval here. They really don't make this easy, even for an expert like me. And we'll go ahead and edit this, this here. And so what we want to do is just go down below and place this in here. I'm not sure what it doesn't like. Invalid actions. Well, it would help if it was a proper action. So one thing I can do here, I'll just go ahead and do this. No, I can't just do that. Then it might open up a lot of problems for me here. So what we'll need to do is, I'll just tell it, I'm getting okay. Cohere model. And I mean, if that's the model, that'd be really nice. We'll go ahead and try that. And this one here is supposed to be our account, but that's US West. So let's see if it tries a bit better here. Here it's kind of grouped them all into one. I need for US East one. Okay. And we'll see if it will update this here. I'm not sure if it's text generation 001. We'll have to double check that. I'm not sure how we would double check that. If we go over to into our base models, it'd be nice if it told us the ARNs. Maybe it does. And so we'll go here and we'll just type in, we'll not type in, we'll just search cohere. And so I'm trying to go with command light here. And so what I'm looking for here is the ARN, which is right here. So that's probably what it wants, not all the stuff that it's putting out. And so I'm going to go back over to here. I'm just going to take this part out and place this in here. And we'll take that comma out. And so it doesn't know what those models are. So it has these actions, but if it says they're not valid, they're not valid. This is what I mean where like the models don't always know, especially when things are new. So invoke model is definitely real. List models is not there. Get model isn't. So let's go look up actions. So Amazon Bedrock API actions. What? Like so much work to get this working. And so what I'm looking for here is things like invoke or model. So we have invoke model, yeah. There's no like get model, there's get foundation model. So yeah, I mean, basically it's just invoke model. So maybe that's all it needs. We'll go ahead and take the rest out of here. And so that's not a problem. We'll go ahead and hit next and save this. And so hopefully now it has the permissions it needs. And actually it's telling us, well, we changed it back to the other one, right? So we'll go back over to Cohere here and we'll choose this one. I thought it was Command Light that we chose. Well, what did we put in there? This one is, which one is it? Command R. Additional models. Oh, that's the text one. I mean, it's totally fine. Command Light text. So I'm gonna guess this is Command Light, okay? And we'll go down below here. We'll try this again. We'll close out this tab. Oh, we have to choose it every time. We'll try this again. And here it says, does not have permission to this model, Command Light 14. Well, I'm pretty sure we gave it access. So let's go back over to here and we'll edit this again. We'll take a look. It is different. In what way though? It almost looks the same, so I'm getting kind of confused. Let's line it up and then we'll know for certain, right? I'm not sure it's just like a font thing. So there is a difference. This one says Command Light text. Okay, so the one that we chose was Command. This one's Command Light. And again, I don't really care if it's Command or Command Light in this case. But we'll go ahead and do this. We'll hit Next. We'll hit Save Changes. We'll give this a moment here. So what I'm going to do is go back and hit Create. There we go. And so now it's in progress. I don't know what this will cost, so just understand if you're not comfortable with it, don't run it. But I'm not worried about cost here, so I'm going to let this run, and we'll be back here when this is done, okay? All right, I'm still waiting for this to complete, but one concern I have is I'm looking at this data set, and it has 23,000 customer reviews and ratings, and that seems like a lot of data. And for what I want to do, I don't want to run this much, so I'm kind of concerned that this is going to cost me a lot of money. So I'm going to go ahead and stop this. And I would just say that it's kind of frustrating because AWS is providing those data sets. They're not making clear the size of those data sets, how much it would consume. So I kind of feel like this is another failure with AWS. I could create a smaller data set and test it on that. But honestly, I'm just going to recommend that you don't even run this because what's the point? As I'm finding this to be a little bit frustrating. It'd be nice if there was some data. Now, here's a question is that if we ran it partially, could we get some of the training data here? As I have no idea how much it's inferred. So we go into this and we don't have anything. So I'm not even sure if it even started up the job or not. But yeah, that's the process of eval. And I'm going to say if you're going to use it, then use your own data set so that at the very least, you know exactly how much is happening here. I'm not going to create one here today. I just don't like the service. I'd probably just use some libraries to do evaluation. I don't think I would do it this way, okay?